Hey, hi. Hi.
And he is Mario, who will be here.
Sure.
You are
I'm Mohammed,
yeah, Mohammed,
and
and Yashovardhan will come.
Yashovardhan is coming.
Okay. And I will just introduce you like, hey,
Yeah.
we have a talk with Mohammed and
Yash.
Yashovardhan.
Feel free. Yash is fine.
On Web3
Yes.
and that's it.
Yeah. On with 3 then what's it's all about in this hackathon. Okay.
And three things. So you need to speak always to the microphones.
Okay.
Yeah, you cannot go
Oh yeah,
over
sure.
there because then there is no recording.
No.
And when
Perfect.
somebody makes you a question, can you repeat the question, please?
Okay.
Because they don't have microphones.
Got it.
Yes.
Got it. Got it.
We'll be telling you when you have. Do you prefer 5 minutes before
Uh, yeah. I think 5 minutes,
and
3 minutes,
2 minutes?
5 minutes or 2 minutes.
Yeah.
Fine. Yeah.
So he will tell you five, two,
Yeah.
yes. And do you make questions answer?
Yeah. Yeah. Sure. Feel free to.
No, it's like if you plan to do that, so that
Yes.
yeah. Okay.
Yes. So we can unquery their issues.
So 5 minutes before we do this, and then you can say
So it's in total it's 20 minutes.
like 18 minutes
18.
because we need to
Yeah.
then move and connect things.
Okay. Yeah. So let's do 5 minutes for Q and A, and then
More on the camera. Yeah. No, it failed. So yeah, don't worry about it. When it fails. Do you want to connect it with this?
oh yeah, just wait. I'm waiting for my Yash, and represent your. Sorry, what? Oh, good. You go ahead and then I'll maybe.
And the prices.
Start to with your partners with your there, also in the pool.
Yep, yep, yep. Hey everyone, how's it going? Awesome. So we're from Web3 Auth and we're gonna start the workshop. Okay.
There are
One
like
moment.
recordings going
Awesome. Hello everyone, I'm Yash from Web3 Auth. Here's my colleague Shabaz as well, and we're going to talk to you about what Web3 Auth has to offer in this hackathon, what are the things we do generally, and how we simplify the whole onboarding process into the Web3 world. And you can, of course, win up to $10,000 worth of prizes we are giving away at ETHGlobal. Okay, so before we start forward, I have a small question for you. Like, what was the first DApp usage experience for you? Like, any kind of DApp you might have used when you were just trying out Web3? Anybody? Like, you were just new to Web3, and what were you doing at that point of time? Like, what was it difficult? Like, was it like intimidating, or how did you actually access it? Okay. Yeah. Everything, right? Exactly. And did you know what exactly was MetaMask and how it worked and things like that? Think about it like as a particular newbie who is not very Web3 savvy as such, right? Like it felt like maybe you have to create a MetaMask wallet, then sign a transaction, and should I create a wallet? Should I not? What it is? So think about as a general user. Think about your grandmom, for example. I will say. So for them, it's like very intimidating, right? You have to understand what are the Web3 wallets. You have to install a wallet extension like MetaMask. You have to onboard to the application. You have to sign everything, set up a seed phrase, a lot of things. And for a general person using Web2, they're like one click Google login, I'm done, I'll start using the application. As simple as that. So this is what we stand for. We think that Web3 should not be this complex. As easy as using a Web2 application. And because of this, if you might have seen, because of these unfamiliar and complex flows, a lot of people have lost their just funds. Bitcoins have been 3.6 million worth of bitcoins have been lost, and this was when Bitcoin was at 30K. So just double it. So there's a lot of money that has been lost around because of this high skill needed just to access these Web3 applications. And this is where Web3 Auth comes in. We help people to use where they're already comfortable with. A simple SSO like Google, Facebook, anything, whatever they're comfortable with, just enter the application, one click, log in, and you are done. Just simplifying the whole thing. And this has increased the adoption rate quite a lot. It is easy, you can easily trust and re-access the same key, you don't have to think about it. And it's highly secure because it's powered by an MPC at the back end. and you are totally non-custodially logging in. So these are the main challenges we tackle with the Web3 Auth MPC: seamless non-custodial key management experiences, compatible with all existing authentication methods that are already there, mostly following the Auth2 standard, Auth2 standard, and it's performant globally and scalable as well. So we have right now a lot of users already using this, over 21 million monthly active users we have right now. So I talked a lot about why we need this and what are the things. I want to talk about how it works so that when you are using it in your application, you actually know what is going to happen. So as you can see over here, it looks like a very complex chart, but you can think about your front-end application being right there. Inside of your front-end application, somebody can just trigger a login. Maybe we are given a demonstration of Auth0. So it can go to Auth0, Google, Facebook, whatever. And from there, these login providers, which are basically present, they give you an ID token, a simple ID token that is the OAuth2 standard. As soon as you get the ID token, you pass it over to the Web3 Auth SDK, and the Web3 Auth SDK will generate a private key for you. And how does it generate is, this particular auth network basically hosts our node, which have a key value pair kind of storage of a part of your private key, right? And what happens is, when somebody gives you the ID token, these nodes get the ID token, these nodes validate the ID token if it's a correct ID token or not, and pass over their share to the front end. Inside of the front end, we dynamically reconstruct the private key, and using that, we can get the final private key of the user. And this is our Shamir secret sharing based architecture. For MPC based architecture, we do partial signing across all the nodes, and those partial signs are aggregated in the front end to form a final signature. And that final signature can be sent to the blockchain to do any kinds of transactions. And you have directly native providers for all the blockchains available, and it's just use it right off the bat. There are multiple ways you can use this. One way is to pass the ID token and everything manually so that you have more control over the flow. It's up to you to use that. Or you can use our plug and play SDKs where this whole thing is managed for you end to end directly as well. So this is the whole Web3 Auth architecture. We'll be going towards talking on what particulars you can do as well, and what are the specifics you can do to win some prizes at this hackathon as well. But as you can see, all the chains, mostly everything, we are chain agnostic, every kind of login out there, and all the platforms are supported as well. You can build upon Android, iOS, React Native, Flutter, Unity, Unreal, and web, of course, all types of frameworks, whatever you like. And you can integrate external wallets as well with us, and you can use them directly through the Web3 Auth. So let's see in action. My colleague Shabazz is here, will help you go through the documentation, show you around with our quick start guides and how it works generally.
Thanks, yes. Hi, my name is Shabazz. I'll be demonstrating how to use it. But before that, let's quickly see if demo works with us. Demo.io. So think of this more of like, if you want to integrate your application into your application, how basically this will look like. Given that the internet is how it is, I'll try to see if it gets through this particular network. If not, I'll just walk you through about the integration guide and how quickly to get you started. But at least I just want to show you how the modal looks like. Maybe this gives you a gist of like how prepared you need to be during the hackathon. But as soon as you integrate Web3 Auth, you will be presented. So this is our plug and play solution. So you don't have to configure a lot of things, just simple lines of code. I'll show you how it looks like. And then you'll be able to do like this, basically Google login or login with any of the social providers, also your email, and the stuff goes on, right? Given the internet, I highly doubt that this will go through, but I'll try my best. Okay, looks like I'm here. And you'll have like all of your details. This particular demo tries to showcase more of your personal info. We have something called passkeys as well. You will be able to register through that. This demo does not show that, but you will be able to do that in your hackathons as well. Like other services like wallet services, NFT services, and whatnot. So let's see how this looks like behind the scene. So this is our quick start, very much easy to navigate from our documentation or our website. So as it goes through, you will be able to select from the offerings of the product, like from plug and play to core kit, right? And each plug and play and core kit will have different offerings from PNP web or the modal, or maybe you might not want the modal what we are presenting to you, or maybe you have an existing design, you just want to integrate it with your existing system, right? So you can choose no modal, and then list goes on from mobile applications from Android, iOS, React Native, Flutter, and Unity, even if you want to integrate with your gaming application. So steps are very simple. You just integrate it, right? And the same goes here. If you want to try out like how this particular thing looks like in Android, when you click on preview, since the internet is not there, you'll be able to present it. A mobile view would be presented, which is an actual application, how it looks like. You can play around and see how basically this looks like. So let's see the the web modal one. The steps are very straightforward. If you see it here, I'll try to hide it from here. The steps are very simple. You install it, or you can choose the dgit command, the one here. So this is the boilerplate. You'll be able to just one click, just download it through the terminal, and you'll be able to run it very quickly using these couple of lines. If not, you wanted to integrate in your existing application, the steps are as simple as that. Like you install it, and then the one thing what you need is a Web3 dashboard account or a developer account, which is free to sign up. Again, the links are here. Feel free to sign up. You'll be able to create a project, because we need something called client ID. And if you want more of the technicalities, like you want to host your own verifier, for example, your custom Google login, you'll be able to do that through the project setup and creating a verifier. So the steps are simple. I just don't want to waste most of our time here about like if you have any queries about this, then I'll straight away jump to the documentation. This is the documentation, web3.io/docs. All of our SDKs are listed here, the SDK reference, everything around that. And I think at this point, I would just want to showcase like what are all prizes we are offering at this hackathon. So there are like a bunch of SDKs that we offer, right? One is plug and play, the other one is core kit. But if you've seen the first one, this is like SFA, which comes under the core kit. So for SFA, we have $2,000 if you integrate it with SFA. For plug and play, there is another $2,000. If you want to integrate with mobile or gaming, then there is another 2,000. Technically, you can get this 3 plus 2 as well if you have like a grand prize for overall, the best solution that people have built using Web3 Auth. And there is something very new about global accounts. So we'll be sharing more of the resources in the partners Web3 Auth, the Discord. So if you have any queries about any of our prizes, what this particular entails, feel free to share that or your questions, or feel free to reach out to me, Yash, Elisha, or anybody wearing Web3 Auth t-shirt. We'll be happy to take your queries, or if you have any integration issues, we'll be happy to address those as well. Yeah, apart from these, Yash, you want to showcase anything else?
So let me just go into each one of these prizes one by one, and what you need to do to actually win these, right? So if I go to, maybe I want to have like a native experience within my application, cloud abstraction on top of Web3 Auth and things like that, I can utilize the single factor auth as well as the plug and play applications over here. Single factor auth needs more a bit of work from your side, but the whole experience will be really good, because here you will be handling the authentication part of it, taking the ID token from Google or whatever and giving it to the SDK. The SDK is extremely lightweight because it just does one thing, takes your ID token, generates a private key, that's it. As simple as that. The particular resources have been mentioned, the quick start and examples, everything is over there, and you can clone it. The bonus points, if you want to win a really good prize on this, is use the Passkeys plugin, we have introduced something new over there, using which you can just do a Google login. Demo about that. Basically, this has a login through passkey as well. Okay, so I think I might have a passkey over here. Okay, so with the easy passkey login, I can just get in. If you do this, you will have extra bonus points over here. If you use WebPriot wallet services, in the demo you might have seen this. So you can use this UI, and inside of this whole UI, you can just configure whatever you want, change your network and things like that directly from the UI. You can have wallet connect interoperability and fiat on ramp as well. So that is also available. Then using wallet pre-generation, which is a new feature, basically without even authenticating a user, you can generate their wallet address using some of maybe the Google email, for example. Use that to airdrop NFTs or airdrop anything you want, even before they have logged into the application. If you use this feature as well, you will get extra bonus points. So the qualification is very simple. You have to just integrate the Web3 auth SDK, uh, get the particular up and running wallet. Inside of that, you just have to add the test tokens or whatever and just demo using Web3 auth. That's the basic qualification requirement for all our SDKs or anything. Just make a demo in which Web3 auth is the main authentication. Right. Next is our plug and play SDKs. Plug and play SDK is pretty simple. If you go to our integration builder, it's literally a 4-step process. If you go to plug and play, you can use either modal or no modal. You can preview those applications here directly as well if you want. And you just have to get a client ID, initialize Web3 auth. You can just directly copy paste this code, and you can just do login, and that's it. It's as simple as that. If you do this and additionally use maybe multi-factor authentication with a choice of MFA, use custom authentication, which is an inbuilt thing you have to use for SFA, but here it's like an use wallet services as I talked about earlier. And if you're using React, you can use hooks. If you use these additional things, you can win bonus points as well. All the resources are directly given over here. You can see the SDK references. If you are a mobile or gaming developer, you have additional things. We have our SFA as well as plug and play. So when I talk about SFA, I talk about CoreKit SFA, CoreKit, then single factor auth. CoreKit has MPC as well. We are not giving out prizes for MPC right now. It's like more of an enterprise SDK particularly. So inside of CoreKit and plug and play, all the different SDKs are over here. And for mobile, if you just integrate any of the mobile SDKs in your mobile or gaming applications, you can win that. Similar points are here for bonus, what we have mentioned above. Shabazz has already talked about the grand prize, and we are mostly looking at the UX, the technical execution we have done over here, the idea feasibility as well, and you can get bonus points if you just share around your project on X and things like that as well. Finally, as Shabazz mentioned about the global accounts, we'll be making a guide very soon. New beta SDK that we have. It's a very low lift. It's a wallet that you can just integrate with and that is also available if you use that, and if you don't want to use excessive, that is also available for any questions. Maybe you want to integrate action, if you want to use us with any chain or anything like that, you can just reach out to us right in the Discord channel. There are multiple things already available in our community. So there's community.web3.io, which is a very active community in terms of all the 90% of the times is already solved over there. Have a look over there as well. So I guess those were the main things we wanted to talk about. And if you have any questions, anything are available throughout the whole hackathon. We'll be here at night as well. So just make sure to check out our booth, and we'll be there across the Any questions, anybody? Yeah, please. So you want to verify whether the user in the backend, basically, whether this user is the correct user or not in the backend, right? There is a feature called server-side verification. If you go to the Web3 or this feature, what we do is we generate an ID token in the front end, which you can send it over to the backend and verify whether this particular person's public key is the same or not. If it's the same, this user is verified. If not, it's a different user. It's a spoofing user. So you can directly do that using this as well. If you have any questions, just come here. We'll just show you how the integration works. World ID integration, you can just use the world ID, generate an ID token, send it over to Web3 or the SDK, the SFA or plug and play, and you can generate a private key. I guess the time is up, is it? Okay.
Yeah, sure.
Okay. Sure. Thanks a lot for joining, everybody.
¿Conectas con HDMI o con este, verdad? Supongo. Sí. Porque es C. ¿Y quieres conectarte al internet? Tenemos el adaptador.
Bueno, en principio creo que no.
¿No? ¿No haces demo?
Sí, bueno, vale.
Te convendría.
Vale.
Vamos a empezar en un minuto. Que hables siempre a los micrófonos. Si alguien te hace una pregunta, repetir la pregunta tú para que se escuche en la grabación. Algo yo estoy aquí. Y te voy a decir 5. ¿Necesitas que te avise como antes?
En principio tengo un contador, pero bueno, nunca está
Es
de
que
más.
son 18 minutos y no 20, porque para darle tiempo de justamente que te conectes.
Vale. Bueno, si me avisas.
Te aviso
mejor.
5 y te aviso 2.
Vale.
¿Sí?
Vale.
Gracias.
Hello. Please raise your hand. How many of you have thought how difficult or complex managing different keys can get? Okay. And also how difficult accessing to these keys can get as well, right? Especially not talking about EOAs, but multi-signature accounts that have multiple wallets. So today, we will be talking about passkeys that offers a new UX improvement to handling all these keys. So the talk is integrating passkeys with the SafeSmart account. My name is Herman. You can find me on Twitter at Hermago. And please, important thing, this is just a developer review. Some things are not audited. So if you are playing around with this, do it in demo apps or testing apps, but not in production yet until the audits are finalized. That will be soon. We will cover a few topics, a brief introduction to passkeys and SAFE and the benefits, how to integrate them with the SAFE Core SDK, what contracts from SAFE are involved in this process, and a bit of the flow, and finally a demo to showcase how the user experience looks like. So let's start with passkeys. Passkeys are a standard authentication method that leverages biometric data like the Touch ID or the Face ID to provide a user experience that is much better. Also, unlike traditional passwords, with passkeys you don't need to remember complex strings of characters, and you can just rely on your physical data. So some of the benefits or key features that passkeys and SAFE provide are simplified authentication. Using biometrics, data, and hardware keys, passkeys simplifies the authentication flow. Also, cross-platform compatibility, as SAFE passkeys is designed in a way that is compatible with multiple devices as long as they support the WebAuthn API. Enhanced security, as the private keys associated with passkeys will not leave the device, the physical enclave in the device, so it's more secure. Also, additional multi-factor authentication with multi-signature. We see that blind signing is getting more common as the UX is improving, so offering a multi-factor authentication is great for the users. Now, audited contracts. This is in gray because most of them are audited, but there's one that still is in the process. And available on multiple networks. You will see in the coming weeks, months, how the contracts that are involved in this solution are deployed there. For now, the demo will be on Sepolia. So let's start with the SDK. And what are the different steps that you will need to follow in order to integrate passkeys in your SAFE account? First of all, some imports you need to do. Creating a passkey using the WebAuthn API from the browser. Initialize the SDK, create a transaction, sign in the transaction with the passkey, and submitting the transaction. So let's see all of them. With the imports, first you need to install two packages, the relay kit and the protocol kit. Please pay attention to the versions because they are alpha version, as not everything is audited again, so please use this just in controlled environments, not in production. And then do some imports from the relay kit, importing the SAFE 4337 pack, and then getting a utility from the protocol kit. Now, to create the passkey, we will use the WebAuthn API that the browser is providing. So there's an object, navigator.credentials, that has a method create that receives an object that is called public key and has some properties inside, like the public key credential parameter with the algorithm for signing. This has to be the same that is implemented in one of the contracts that I'll show you later. A relay in party information, user information, and some other data. You can get more information on our docs if you want to define this. Sorry. At the very end, you need to get the passkey object, which is what we are looking for. It's an object that has an ID for the passkey and some coordinates. And you can get that with the extract passkey data method that is receiving the passkey credential. So once we have the passkey object, we can initialize the SDK. We are going to do this passkeys integration using the 4337 flow as well, because we don't want just to abstract the keys, but also the gas Otherwise, it wouldn't make much sense, right? So the SAFE4337 pack provides a method init to initialize it, where we can pass a provider, the network we are using, also a signer. In this case, is the passkey object we created before. It could be a private key or whatever, but in this case, we want to use the passkey. And then some information from the bundler and the paymaster. We are using Pimlico infrastructure here. So the API URLs, and also a sponsorship policy ID in case you want to get your transactions sponsored. At the end of this talk, you'll see, well, I will provide you one. So during this weekend, you can get all the safe transactions using this flow sponsored by Pimlico. And sponsored by us using Pimlico Infra. And then you can define some options to configure your safe if you want more owners apart from the one you are defining, like the passkey or the threshold. Here is one, but it could be different. Once we have our SDK instance initialized, we need to create a transaction, the one we want to execute. For that, we need to define the two-value data of a transaction. We can even do a batch. So here we are creating an array of transactions that we pass to the create transaction method inside the SAFE4337 pack. This will return a safe operation that the signers of the safe need to sign. In this case, because we initialize the SDK with the passkey will be signing this. How? With the sign safe operation method. Here, after calling this method in the UI, is where the user will see the pop-up, and they will need to provide their credentials or the biometric data. Once we have it signed, we can submit it with the ERC4337 flow by calling the execute transaction method. There's an executable property where we pass the sign safe operation. And that's it. In the future, for your safe, you want to add more passkeys. This would be something similar. There is a method, in this case, in the protocol kit instance that you would need to initialize as well. And the function create add owner transaction will return a transaction with the right data to add a new passkey. So after that, you would need to create the safe operation, sign it with the passkey, and execute it. So one safe can have multiple passkeys if you want. Now let's see what are the contracts involved in this solution. It all starts, of course, with an account that is safe, and safe can be extended, the functionality, with modules and fallback handlers. Have you heard of them? Can you raise your hand? Okay. Modules basically allow to execute safe transactions with a different way of validating the signatures, so they can have root access. And the fallback handler is a contract that can implement some methods that are not implemented in the core account, but when these methods are called in the account will fall back. So it's a way to add more functionality. For these two, we will use, or we are using, the SAFE4337 module, which is a contract that is adding all the compatibility with the ERC4337, and we need to enable it as a module and as a fallback handler. Everything is just done by the SDK. Here I want to showcase a bit what is happening behind. So we don't have two instances, but one instance that is used with these two different roles. Now, the account is multi-signature, can have multiple signers, but if you are using a passkey, you need to set up that passkey as a signer. When I say that passkey, I'm referring to a contract that will validate the passkey signature. Here we are using the Safe Web Authn shared signer. This contract is a singleton in every network or in any network at some point. That will be able to, that should be enabled or should be added as a signer on each account if you want to use a passkeys. If you want to use more passkeys, then there are other contracts like the safe WebAuthn signer proxy that can be added, and that would be used for a second signer, and we can add more and more. This proxy is a singleton and also has a factory you can call to deploy it. And the main difference is that if we are deploying an account with the 4337, we just can deploy one contract, which is the safe, and not a proxy at the same time. So the shared signer should be used for the first time as it's already deployed there. And then if you want to use more passkeys, the SDK is doing this, it would deploy these other contracts. And now with the ERC4337, how the flow would look like is something like this. Are you familiar with the ERC4337 flow, validation and execution phases? Well, it starts with the bundler, or after you create it and sign the transaction, you send it to the bundler to the entry point, and then the entry point is calling your safe to validate the signatures, as it is providing the transaction and the signatures. The safe is forwarding this to the module that will process it, and to check the signatures, it will detect that it was signed by a contract, the one from the passkey. So it's not able to check the signature, the account itself, so it will need to check with the shared signer. That will also check with the WebAuthn, that is a contract that Safe created to do the validation of the signature, and at the end, it will return to the entry point if the validation was successful or not. After that, the second part, which is the execution phase, the entry point will call the execute user op in the safe. The safe will let the module to create a transaction and to send it to the target. This was very fast, but now we will see a demo, hopefully. If I can share my screen or stop it. Yes? Okay, so here is how an integration of safe and passkeys in an app would look like. We have, this is like the login page where you can create a new passkey or use an existing one if you are an existing user. So if we want to create a new one, we can click. We can decide where we want to create the passkey. We will select now the local host. The passkey is called safe owner. Will only be saved in this device. I can use the Touch ID. And now it is interacting with the WebAuthn API from the browser. And you will see that it calculates the safe account that is not deployed yet until the first transaction is executed. And then we will be able to mint an NFT gaslessly. So this is the safe that will be ours. Now we can mint an NFT. This safe is configured as a one owner and threshold 1. So it will ask for our signature. And we will use the passkey. Okay, with the Touch ID. I'm signing the transaction, and now it's executed. So this transaction, what it did, we can see it here in the Safe app. We can go to the settings. We see that it has an owner. This owner is the contract that we saw before that is associated with the passkeys. If we go to the modules, we see that it uses the 4337 modules. And if we go to the transaction, we see a batch transaction executed with the creation of the safe and the minting of the NFT. If you want to get more information, you can copy the transaction hash, paste it in Tenderly. It may take a bit of time, and there you can see, yeah, it takes a little time get it from there, and there you can see all the trace of the transaction. But we don't have time for that, so let's go back to the slides. And after the demo, we have some resources on GitHub with the SafeCore SDK if you are interested in seeing how all this integration is implemented. Safe modules if you are interested in seeing the implementation of the contracts that we showed, and the safe modules deployments to see where these contracts are deployed. Also, I recommend checking the docs.safe.global, where we have some guides, tutorials, and some context on all of these regarding passkeys. And finally, what we are, or where you are expecting, the bounties we have 3 tracks. The first one is 4K, 2 prizes, in total 4K, for the best app integrating passkeys, creating a dApp similar to the one that I showed that showcases this, this way of signing. The second track is related with the ERC 7579. You can read more in the website. 4K as well, 2 prizes. And the last one is like a wildcard for the best app related with Safe, 2K. And if you want to get your transactions sponsored this weekend, you can get this code and copy-paste it in the initialization of the Safe 4337 pack. Feel free to come to our booth anytime to, well, to check any questions, and thank you for attending.
We don't have time for questions, but if you have questions, you can go directly to the booth where he is.
Sorry for the...
No, gracias, gracias. You don't need Ethernet, right?
Okay, no, I just gonna be the slides.
I'll put the slides now.
Yeah. Should I start? All right. Thanks everyone for being here and for taking interest in Nethermind's bounties. Here I'll briefly discuss the 4 of them, but I'll focus on ZKML. So I'll speak about ZKML first, and at the end I'll briefly mention the other bounties and point you to people in our team that you should speak to for more information. Okay, so our ZKML bounty has to build a project that combines ZK technology and machine learning. And of course, this is a very open-ended description, so let's look at some possible approaches that you may take to this bounty. So ZKML, technically, we use the term ZKML to refer to any application that uses ZK technology in combination with machine learning or AI. So here, by ZK, we don't specifically mean zero knowledge. We mean succinctly verifiable computation or zero knowledge. So we don't really care. It is possible that we don't have actual zero knowledge and we only care about succinctness. So that's perfectly valid. So ZKML is a wide area of research and engineering. Some of these areas that I think are very interesting, at least for this bounty, are proof of correct inference, proof of training, and federated learning. So let's see, what's proof of inference? So in proof of inference, we have a model, let's call it F. And let's say that this model is signed by a trusted party, and let S be the signature. So in proof of inference, there is a public input, X, and one wants to create a ZK proof for the following statement. One wants to prove that there is a model that has a valid signature, and that when run on input X, okay, so here it should say X. So when run on input X, the model's output, f of X, satisfies some property. For example, f of X is bigger than 0. So this is a bit abstract, so let's look at an example. So say that F is a model that takes a face photo and determines if the face corresponds to a legal citizen of the country. And S is a signature of the model that is made by the government. So now Bob could check that Alice is a legal citizen by checking that S is a valid signature of the model and running the model F on a picture of Alice's face and checking that the output of the model is, say, positive. Okay, yeah, so this is exactly the copy of the example. However, you could do that, but this means, for example, that every time that Alice wants to prove that she's a citizen, the whole model needs to be run. So Bob needs to run the model over and over again. So if Alice wants to prove that she's a citizen to several parties, then each one of the parties has to run the model. So an alternative could be that Alice creates a succinct proof pi of these two claims, that valid signature and that F, the output of the model, is positive. So it creates a succinct proof, and this way, whenever Alice wants to prove that she's a legal citizen, Alice just sends the proof, a picture of her face, and the signature. And then Bob just verifies that the proof is valid. So that's a typical use case of proof of inference. This is, for example, how WorldCoin wants to use ZKML. So yeah, so in WorldCoin wants to do precisely this, and in here S would be a signature of WorldCoin. And note that Bob doesn't even need to know the model. It just needs to know that it is signed by a party it trusts, like a government. Okay, so yeah, here we only care about pi being succinct. Here we don't really care about zero knowledge. We don't want to hide data here. Here we just want that the proof is short and that it can be verified very cheaply. And yeah, depending on the application, maybe F is not signed, it's committed. Maybe F is public. Yeah, so, and this branch of ZKML is currently a very hot topic of research and engineering. So I highly encourage you to take a look at this one if you are interested in ZKML. So in then there's another branch of ZKML, proof of training. So in proof of training, there's usually a private data set and a model. So I denote the model FWX. So here X is the input to the model and W are the parameters. And in many applications, you have a commitment to the data set and to the model, or to some of them. And recall what does training mean? Training a model on a data set D means finding parameters so that when you use these parameters on the model makes good predictions on this data set. So the goal of proof of training is to create a ZK proof of the following statement. I know a dataset D whose commitment is some public value, and I know some parameters W such that the model with those parameters commits to some public value, and these parameters are the result of running certain training algorithm for the model on the dataset. And yes, so this is exactly the end of the last slide. And why would we want to prove this? Well, there are several interesting use cases for proof of training. There's distributed training, where a model owner distributes the training of the model among untrusted workers. So there's several untrusted workers. You want them to train your model. So you ask them to train the model and also provide a proof that they trained it correctly because you don't trust them. So you could create some kind of marketplace of trainers. Or, for example, arbitraging copyright claims, where a model owner proves that the model was trained on data that doesn't contain copyrighted data. Okay, so yeah, proof of training is quite a tricky area of ZKML, and this is because, as you know, training a model is orders of magnitude more expensive than running a model. So, just proving proof of inference is already quite a tricky area of ZK. It's quite hard to do efficiently if the model is large. So proof of training, for example, large language models is sort of out of reach at the moment. So this track of this approach to our bounty is kind of more difficult than proof of inference. But yeah, if you want to focus your project on proof of training, that's perfectly fine. We will take into account that this is a harder aspect, that this is harder than proof of inference. And yeah, if you want to do this, I recommend you focus on small models, that you prove training of small models. Perhaps classical models instead of deep learning models. Or if you want to work on deep learning models, then just use models with a small amount of parameters. Okay, so proof of inference, let's go back to proof of inference and some ideas on how you might tackle this topic. So I would recommend you look at existing ZKML solutions and improve some parts of it. In the bounty description, we have several links. And one of the links is awesome ZKML. It's a GitHub repo maintained by WorldCoin, and there's lots of ZKML solutions in there. So one possible way to start the project is to check those and look at one of them and try to improve a small part of it. So possible aspects of ZKML that I think need improvement and that at Nethermind we are working on improving are the following. The treatment of floating point arithmetic, the fact that models in deep learning are self-similar, I'll explain what this means in a moment, and the fact that there's many non-linearities in the models. And yeah, now I will talk about these 3 points, but a very important point, if you want to work on this bounty, be creative. The best thing you can do for the bounty is to be creative and have a great idea, even if, yeah, so creativity is gold, so don't limit yourself to what I'm saying here. If you have nice ideas, please pursue them and surprise us. Okay, so one area of improvement, I think that like it's low-hanging fruit for ZKML is leveraging the fact that models are often the result, like the computation of a deep learning model is often the result of applying the same computation many times, over and over again. For example, in a deep learning model, there's maybe a layer, like say a convolutional layer that's applied dozens of times in a row. And even, for example, in a single layer, there's the same computation that's repeated many times. For example, a convolutional layer applies the same filter many times for many patches. So it applies the filter to lots of patches of the input, right? And the same matrix vector multiplication can also be split into chunks of computation where each computation is the same. And a popular technique to approach computations where this happens, that computations that can be split into smaller computations that look the same, is to use folding. So in a folding scheme, just a crash course on folding schemes, there's a prover and verifier. The prover has to two statements that wants to prove, and then the program verifier interact to create a new statement, so that if this new statement is valid, then the two initial statements were valid. So in more plain terms, a folding scheme reduces the task of proving two statements to the task of proving a single one. So you can use folding schemes to prove large statements. So say that XW is the large statement. You can break this large statement into very small parts, each one from the same relation. This means that it's basically the same computation. And then you fold all these small parts into a single one, and then you prove the folded instance. So I think that ZKML is ready for this type of technique. What's the time? 5 minutes? Okay, so let's look at this one, and then I'll skip the later point, and we can discuss after the talk. Okay, so deep learning models deal mostly with linear operations. Most operations happening in a deep learning model are inner products or matrix multiplications. However, there's crucial nonlinear operations happening in the models, such as ReLU, softmax, max pooling, etc. And proving this in a ZK snark can introduce a huge computational burden, because as you know, ZK proof schemes rely on proving statements about field operations, additional multiplication between field elements. However, ReLU and softmax, max pooling, etc. have nothing to do with field operations. And writing these nonlinearities as additional multiplications between field elements leads to a huge blowout in the statement you are proving. And yeah, a popular way to tackle this problem in general, not only in ZKML, is to use lookup arguments. When you want to prove something that's very hard to arithmetize, you can use a lookup argument. This is already being done in some ZKML applications, but I think it can be done in a much more deeper way. So if you want to know more about this, please come talk to me afterwards. Okay, so I'll skip this explanation of lookup arguments. Yeah, and so yeah, that's my overview of this bounty. As I said, please talk to me if you are interested in working on ZKML. I'll be very happy to expand on any of the points I mentioned. Our other bounties are the following. Security-driven development. In this the goal of this bounty is to design, to develop some cool code and focus on how to make sure that the code is secure. So here we suggest you either use fuzzing or formal verification. Then another bounty is large-scale compute. In this bounty, the goal is to leverage L2 rollups where fees are cheap, so as to build an application that's not possible to run on Ethereum, an application that uses a lot of computation. For example, some game that requires a lot of computation, or maybe training models on StarNet, for example. And then pre-confirmations innovation, anything that has to do with pre-confirmations, even if it's just a theoretical exploration, is welcome in this area. For if you are interested in any of these bounties, please come talk to us in our stand. And yeah, as final remarks, we are hiring. So we are both hiring for full-time positions, and then we have a wonderful internship program. Yeah, if you are interested in working with us, you want to work on any of the topics I just talked about right now, or many more, please reach out to us, and please reach out to Aya in the back of the room. Thanks.
Sure. If maybe if if somebody has questions, they can go on to both with
Yes.
I see that maybe he has a question.
Okay. Yeah.
Thank you. Do you need internet?
I have it, yes, I am connected.
Yeah, but maybe it might fail.
Okay,
So we have Ethernet or
Okay.
C,
yes, it is C, but this is not C. This is better to be the,
HDMI.
yeah, let's try. Let's wait one, and yes, now the other. Only to be sure that we don't miss out. Okay. And did they have the sign on? Do you know if it's okay?
Yeah, they get it there.
It's okay?
Two things.
Okay.
So please speak directly to the microphones.
Can you have another hand mic? We need two mics.
We don't have the mics. There are only these. That's what they told us. Yes. Yeah, sure. And the thing is that if somebody makes you a question,
Okay.
you need to repeat the question to the microphone. Please.
Okay. Okay. Be together. Thank you. Hello, hello.
Okay, you got it. This for me? Thank you. Wanna go
Because
there?
we can be nearby because like the video is only with here. Sure. But not working. Okay. Okay. Can I start? Yes. Okay, welcome everyone. So we are here to talk to you about Chainlink and how to build cross-chain applications with Chainlink CCAP. I am Sol, and these are my networks, and feel free to follow me and discover what we are doing, what we will do in the future. And I came from Brazil, and
And yeah, my name is Andre. This is my Twitter. I tweet around about Chainlink, Solidity, Rust sometimes. And this is my newsletter. I started writing it pretty soon. It's called Smart Contract Design Patterns. It's about smart contract design patterns. So if that's interesting to you, you can sign up.
yeah, so let's go. We are starting talking about our abouties. Probably you saw it before, but you can choose two different tracks. One is to use CCAP, and the three best projects can win 2,000 each, or you can use the other Chainlink services and win 2,000 each. We have two bounds on this, and maybe you are using more than one Chainlink services and you can win both of these. It's possible. And this is the most important care code for you. So if you'd like to read this, then I know that I have more care codes in the middle, but it's everything that you need to this hackathon. Yes, almost done. Okay, so let's go. And I would like to talk about oracles. What is an oracle?
Yeah, sure. So essentially, Oracle is by design any off-chain component that can provide off-chain data and computation. So oracles essentially connect real world with your smart contracts, and Chainlink is a platform for Oracle services. We have a bunch of Oracle services, but essentially you have some kind of data sources and external resources, and you can easily connect those with your smart contract, whatever that is, and then perform some computation on chain.
Perfect. And the best related to Oracle, it's so important that Oracle have a decentralized Oracle network, because the way that you are bringing the information inside the blockchain is the key. So even if the information came from only one source, you can have a consensus to save this information inside your smart contract. And let's talk about a bit about the chaining service itself. So we have some services related to data. Would you like to talk about that, Andre?
Yeah, sure. So if you've been following chaining for a while or been in this space, you'll probably say that chaining is an Oracle service that provides price data. But in the same way, internet is just for email or Amazon is just for books, chaining is just for price feeds. So we have like much more services than just price feeds. Like price feeds are just subset of data feeds, which can be like rate and volatility feeds, NFT floor price feeds, all that other stuff. So yeah, all of these services you can get using chaining, and you will be eligible for a hacked and bounties if you use any of these. And obviously we're here to help you.
So the other services that are not related to data, for example, VRF can be used to generate random numbers. Also, you can use automation to call any function inside your smart contract with the rules that you can define. Like you can define the conditions, or can be called by 1 day or 1 hour or 1 minute, or even related to some log. If that log appear, you emit that event, then you can have some function be executed. And also talking about functions itself, we have the chain-link functions that you can call any external API. Even if you have secrets, you are writing a JavaScript code inside your smart contract, and then calling that information and having this information inside your smart contract as well. And remember that we are not a blockchain, we are agnostic, and we are deployed, our services are deployed in many blockchains. And what's CCIP?
Yeah, sure. So we have a specific bounty for CCIP, and we want to spend some time talking about the CCIP. So this is the high-level architecture of CCIP, and that's pretty much it, what you need to know about CCIP, at least for this hackathon. So there is a router contract, so CCP router contract, one router contract per CCP-powered blockchain, and that router contract actually handles incoming messages. So if you want to send a message, cross-chain message, that can be tokens, data, or both, like programmable token transfers, where you can transfer both tokens alongside some data, then you can just call the CCP send function of the router contract, and that's it, pay for fees. And similarly, how you can send a package using UPS or FedEx, whatever, you just pay, give them the package, and they will handle the rest, even if it's like a overseas flight or whatever. That's why if you go back to the previous slide, please, you can see that in the middle we have a CCIP, which is kind of like a black box, and in the documentation there is like a broader architecture of it if you want to take a look at it. But essentially, you just outsource your transfer of messages to the CCIP, and then the router contract on the other side will deliver the message eventually. And we have Explorer to track this message transfer in real time, and that's pretty much it, what you need to know for CCP. So this is probably the most important slide for you. Just understand it like this, and that's it.
So, and I'm doing a demonstration for you now. So I'm transfer USDC from Avalanche Fuji to Ethereum Sequoia. I'm using Avalanche Fuji because between the test nets, this will be the fastest to do here. The other one, maybe I cannot do like in 5 minutes. And these are all the requirements to do that. You have the slides, the presentation, so you have all of these. You can do this done after. Also, I'm using USDC from Circle. So here is the Circle faucet and the way that you must get the address and add it to your wallet as well. And this is the content that I'm using now. You have this, and it's time to do it. So I deployed the content like 1 minute ago, but maybe I can deploy again and show both to you. So this I made 1 minute ago, and I'm doing another one just now. So I'm here, and I'd like to deploy. And probably my MetaMask is locked or no. Let's see. It's everything right here. Should deploy. It's interesting when you are live and the things didn't work. Oh, yes. It's a bit slow, only this. Okay. So we are ready. Great. So I'm deploying a new version of this. If I scroll down, let's see what's happened with my content meanwhile. I'm importing the router So my content is communicating with the router that we showed a few minutes ago. And also I have the client to have the structures that I need to send a message. I did one, so I reject that. I have all related to ERC20 token, also to interact with this. And then here I may handle the errors here. And I'm initializing this, and in the comments you can use another chain as well, because I put the way I got the chain. So this is the router that I'm interacting with. This is the link, because I decided to pay the fees using link. And Andre, where I'm paying the fees? I'm paying the source destination. What's happened?
Yeah, sure. So you'll just need to pay for fees on the source chain whenever you send the message. Can be paid in link, can be also paid in native coin. So you're just going to use message.value if you need, or you can use the wrapped implementation of that native coin. So that, for example, on Ethereum Sepolia, you can use wrapped ETH as well to pay for fees. And essentially, you're just paying the off-chain dons to transfer the message on the other side. And that's it. Like, you just pay for once, no spinning up any off-chain components or nothing. Simple as that, really.
Perfect. And I'm doing this using USDC. So here I have the USDC address, the token that I'm sending. And I'm going to Sepolia. This is the destination chain selector. This is for Sepolia. And you can find all of this here that I have over there on my content as well. So we are going from Fuji. This is the router. This is the link token. I'm going to Sepolia, so this is the destination chain selector. Everything is in our documentation. And okay, this is the event. When I do that, I'm initializing everything, and this is the most important function, that is the transfer. I'm doing this first, and then I can explain this part for you. So, okay, I deployed the content. Where is my content? I think it's here. This was just now. I must do two things now. First, I'd like to have some link inside my content to pay the fees. Let's do that. So I'm here. I'm going to tokens, link, send. For my smart contract address, I'm sending like 2 or 3. Yes, it's a bit slow here. It was better when I was not on the normal.
Yeah, what she's doing now, like her contract assumes that links are part of the contract itself. So she's funding basically her contract. But you can also just save transfer from inside a send function if you don't want to have it like this. So you're completely flexible when paying for fees, just FYI.
Exactly. You can see over there, like if I go to my transfer function now, you can see that first I'm creating a structure, in fact is an array that I could even transfer more than one token. For each token I must say the address of the token and the amount that I'm sending. Then that array of tokens will be here in the message. This is the struct of a message that we have in the client of CCIP. So the receiver can be any account because it's only tokens. If it is like messages as well, external account cannot receive a message. So for this must be tokens. And any data, I could, for example, send the token and send a message. What I'd like to do with the token on the other side? I'd like to stake, I'd like to do a swap. I could do everything or anything here, defining the data part. And this is the token amounts that we said before. And I don't need to have any extra argument here, but for example, if I'm minting an NFT, I'm calling the mint function in the other blockchain, I must increase the gas limit. And here I'm telling that I'm paying the fees using the link token. Okay? And let's see what's happened here. It is still waiting. Yeah, I'm so glad that I did this before, because at least I have one done to show you. And come back here, you can see that the router is calculating the fee to us. So I am in the Cersei blockchain, and the router is going to the destination blockchain and getting the right fee related to the size of my message. And here I can know how much I must spend in the Cersei blockchain. And I'm also checking if I have enough link on my contract to pay that. Another point that's important, I'm sending USDC. So I'd like to be sure that I have enough USDC on my account. So the USDC is not on smart contract, it's on my personal account, my external account. And this is the second part that I must do. Like I must approve this contract to use my USDC. So I came to the Explorer in the address of the USDC here. And this is the address of my contract now, the new one that I just deployed. And I'd like to approve to use one USDC. Is one in 6 zeros because we have 6 decimal places in some place here. Let's do it. So I'm approving the contract now. After that, the contract will be able to get the USDC in my external account and send to the other blockchain. Yes, it's really slow now. Okay, next approve. Okay, this is what you are saying here. I'm checking the amount and transferring the amount from my external account to the contract, then approving the contract to send to the other blockchain using the router. And after everything is checked and everything is good, then we have the CCIP router sending the message to the destination chain selector. Okay, we are almost in that point. Let's see if it's confirmed. Yes. So if I go here now, I can use it. This is the last one. I can transfer. So I'd like to transfer to my same account, or no, I'd like to send to another account. And come back to the other because I only got the address. So I'm sending to another account, and it's the same, 1 and 6 zeros, the decimal places. I'm sending from Avalanche Fuji to Ethereum Sepolia. I click on transact. After I approve that, we are explaining more with a kind of overview of the other parts as well. So I think we are only waiting now. Okay, we are waiting. So let's go to the presentation a bit more and understand this part. So Andre, what about you to tell them what is happening now?
Yeah, sure. So I'll try to do it quickly because we're running out of time. So this is the broader architecture from that previous slide. So we can see here that she is interacting with the router contract on the left, calling the CCP send function. And now we are basically have 3 off-chain components. Committing down is listening for the events from on-ramp contract, which will interact with the token pools if you're sending tokens, which is happening under the hood. Then it will post a report of that batch of messages on the other side to the commit store contract, which you can all see on this screen, unfortunately. And then risk management network will do the same thing and also vote on that batch of messages. So it can be either cursed or blessed. If blessed, that's good. That's what we want. When we see a blessed signal, the executing dawn will interact with the off-ramp contract to mint or unlock the appropriate, the same amount of tokens on the other side, and then the router will just deliver the message. So that means for you, if you want to limit who can call your CCP receive function, you can put a modifier to say that only router can call it, and that's pretty much it.
Yes, amazing. Let's see what's happened on practical, because I already sent the transaction. If I got the ID of my transaction and came to the CCIP Explorer, probably the search is already finalized, and we are in the moment that we are blessed, maybe, let's see, I don't know. Maybe it was fast. It's looking for my transaction now. Okay, so it's been like, we have, yes, now yes. Okay, we have the search finalized and we have 2 minutes here to wait. Meanwhile, we are waiting, so let's come back here and talk about, okay, I'm waiting, but we are in a hackathon, we must do everything so fast and you don't have time to wait. So use the local simulator.
Yeah, sure. So if you go to our GitHub, chainlink-local is the CCP local simulator. So instead of building directly on testnets, we can see now that we are waiting for transaction to complete on a testnet. But imagine that you have a bug or a flaw or something in your smart contract. Then you will need to redeploy, deal with gas, with faucets, with tokens, with all that stuff. With Chainlink Local, you can literally build locally in Hardhat, Foundry, or Remix, whatever your development choice is, and once you're ready to move to testnets, then you can easily move to testnets, and we have a brand new faucet for that, where you can get multiple different tokens, from multiple different blockchains to multiple different receivers on the same request, which is pretty cool, pretty powerful.
Yes, and this is the multi-chain multi-faucet.
Yeah, looks like this. So just select, I want this amount of token from this chain, that chain, these receivers, hit request, and that's pretty much it. You're ready to move to.
So why CCIP is your interoperability protocol? So you have this local simulator, this new faucet multi-chain, you don't need to run any kind of off-chain infrastructure, and you can send the message and the tokens in the same time. So we can have this kind of programmable token transfers. And remember about our bounties again. To wrap up, you can use this with Ethereum, Arbitrum, Basis, Celo, and Polygon. They are here as well. They are sponsoring, and maybe you can win both bounties because using them and using us. And only to finish, let's go to the presentation. If you didn't get the presentation yet, you can get it now.
And yeah, if you have any questions or anything, we'll be around here or at the booth because we're out of time. Sorry.
Okay. And this is done. Let's see. Finish.
That's it.
Yes.
Thank you, guys.
Thank you.
If you have questions, please go to the booth. Then they will be there. Thank you very much.
It's 20 minutes. Oh, no.
Because we need to change.
Okay. Okay.
Thank you very much. By
Thank
the
you.
way, check your computer because it was vibrating, but for the frequency maybe they were maybe check with them just to ask. So
Do I need to change the frequency?
no,
okay.
it was working with MacBooks very well. This is better now. No, sorry. Yeah.
I have HDMI if you want.
Best with
Best?
this.
Okay.
It has been working, and we just did with the HDMI, and it didn't work.
Yeah. Is it good? Okay. Yeah. Are we good to go? Good. So, welcome everybody. I hope you're excited to start hacking. It's fun. I have some experience there and I liked it a lot. So, I want to help you with TLS Notary. So, I'll start the first part just introducing what TLS Notary is, and then I'll give a very quick demo to get you started. But we also have a booth at the Ethereum Foundation. So if you have further questions, you can find us there. So first, the motivation, why would you consider using TLS Notary? So I assume everybody knows HTTPS. So TLS is the S, the secure in HTTPS, and it's used to get data, Alice can get data from a website. what is data? It could be identity information from a government website, it could be balance information from a bank, it could be social information or just gaming stats that you want for bragging, for example. So what TLS is a very helpful way to get data securely from a website, but it doesn't have a solution for sharing data with a third party, which I will call Bob in today's talk. And so Bob could be a KYC provider, a creditor, somebody who wants to use that data. And so what I expect for in this hackathon, most of you will have the perspective of Bob, where you want to help Alice to provide her with a service, but to do that you need some information from her. And so, as I said, TLS, make sure you can get data securely from that website so you know its origin, you know but nobody changed something in between in that channel, and also that nobody can listen in. But because it uses symmetric encryption, you cannot simply pass on that data to somebody else. And so that's where TLS Notary steps in. So we have a solution where Alice and Bob can do the TLS transaction together. And so it has all the properties of TLS, but in addition, it makes sure that Alice can pass on her data to Bob securely. Bob does not have to trust that Alice doesn't cheat. He can check it. And also, it does not need any changes to the original website. So this kind of unlocks all existing data on the internet, and your app can compose different sources and provide, implement new applications that way. So what's the secret sauce of TLS Notary? We do the TLS connection with the multi-party computation. So that means that Alice and Bob have to do all the key exchange together. And so the advantage is that Bob, during that TLS connection, only sees encrypted information. And at the same time, Alice cannot do any requests or decryption without the cooperation of Bob. So Bob also knows that Alice cannot cheat. Of course, there's no free lunch either, so there is a cost. So there's definitely higher latency in that connection, and also there's a high bandwidth, so lots of encrypted messages that needs to be exchanged between Alice and Bob. But the good news is it works in a lot of cases. So I told Bob only sees encrypted information that would be useless. After the TLS connection is closed, Alice can then share the actual decrypted data with Bob, and so TLS Notary has an option there to offer redactions. So what I showed here with the red squares is that that's kind of information is redacted when Bobs get the data, but still Bobs know that the unredacted data is all correct. It's not easily available yet today, but you will also be able to do zero knowledge proofs on that data that's hidden. So instead of disclosing your address, you can give information about it's not in the US, for example. So in a nutshell, so if you want to share data in a secure and privacy-preserving way, consider TLS Notary for your hackathon projects. So use cases is everything where both privacy and security are important. So things like identity, financial information. So you could prove real-world assets, like you could make your user log in to the Tesla website or to whatever website to prove he owns stuff, or that he bought stuff in certain stores if you want to have like a marketplace. Or also, like I heard somebody at the booth earlier said they were looking into like gaming assets stuff, or like gaming statistics, all this kind of things become available to do stuff and combine it in new ways, even if the website doesn't offer an API for that itself. So again, the data becomes composable. So it's already used in the wild. So ZKP2P did a hackathon in India where they prototyped this. It's now available online. OpenLayer did a hackathon in New York where they built this bragging website where you could prove your GameStop wins or losses, which is nice. And Opacity Labs made something with data from 23andMe, where you could prove your Neanderthal index or your inclination towards baldness. In the previous version, there was only 3 parties. Sometimes you want reusable proofs where both verifier A and B want it. In that case, you can separate the MPC, the multi-party TLS, to a trusted neutral party, and then have the prover store that proof. And then if the verifiers trust that notary, they can actually use that proof without being online together with the prover to do the actual TLS transaction. So now let's switch to the demo. For the demo, I'll show you our browser extension. Oh, sorry. The advantage of the browser extension is that, so to log into websites, you often need the cookies. And we have prepared a demo here where we will prove that we received a DM message from myself to the TLS Notary account. So when you click this, you get this checklist with steps, like first make sure you're logged in, and then it needs, like you need to select a direct message. So when I do this, I can click the check button here, and now it starts notarizing, so checking this request. So I'm now using a notary service on my own laptop to make sure it's fast enough and we're not limited by network speeds. And then you get this proof where you see, I don't know if zooming in works, yeah. So where some stuff like access tokens can be redacted, and then you get the response, and there should be my GM is in there. That's the response we got for the service. So now we have this signed data that your app could use. So this is extensible. So if we switch to VS Code here, you see that you can implement TypeScript where we have a config.json where you configure the steps that needs to be done. They each have then an implementation where you check whether you can move to the next step. And it also has some, but that will change in the future, but already has a permission system where you also kind of protect the user of not having crazy plugins that steal all the user's data. But it's already very approachable for you to start developing plugins. And then the most interesting part is mostly that you need to get access to cookies. So in this case, it's from the Twitter servers. And then you compose a request where you set the necessary headers. So for example, here we reuse the authentication token that the browser was using, and that way we get the response we need. And we can even do some redaction in there. And then it's just a matter of, if only I could type, to do a build. And what's actually happening here is we built a WASM plugin. I don't know if you heard of XTism before, but it's not that important. But now we can open this build result, which we can now add to the browser extension. We can add a plugin here. And then, yeah, it's already in the correct location. So the user gets some information like, don't just install everything. So this one will have access to these kind of cookies. We'll allow it now. And now I can run this proof that I have a Twitter profile. So the proof should arrive shortly. I think I sped run through my demo. What also important to know, so that's the site to get the data. Of course, your app will also want to use that proof to verify that the proof was correct. So if you go to the TLSN extension repository, we added the wiki for this hackathon, where we also have this TLSM Connect provider, where you can, as a website, connect to our extension, request access to proofs. Then you get, again, you need the user consent, and then you can verify the proof and use that data in your application. Either it's to do something on-chain or off-chain. TLS Notary is very flexible. Only your imagination is the limit. And also the data size. So if possible, look for APIs that give you just the result that you need, and not like, if it's server-side rendering, that's too much data for TLS Notary to handle today, but we're of course always pushing that limit. Kilobytes. Yeah. So like the lower kilobytes are no problem, but then like 10, like 50 kilobytes, that's already starting to get tough. Yes? Well, so the request is to the upstream server, so... Oh, at the verifier side, there's no problem. But so the limit is because it's all so MPC, that's like garbled circuits, oblivious transfer, so there's overhead in there. And so there's lots of communication between the prover and the verifier. If you do it with the notary, then it's similar with the notary. Worth mentioning is that at PSE, we do run an example notary server. So in the hackathon, feel free to use that. The documentation is on our website. So that's definitely an option. And then for the hackathon, we have 2 bounties. So TLS Notary itself is written in Rust. So feel free to also just implement a server that's something funky in Rust, or use our new plugin system to just fetch the data, do something with it. So we have a prize pool for new plugins, so that just like figuring out how do I get data from the data sources. And if you have new use cases, yeah, that's also, we're very curious like what you guys will build with it. So in that case, so the question is, what if there's extra features in the backend? So in most cases, I think you can solve it with selecting the correct cookie. If they, of course, they can change their API any day, and then you need to update your plugin. But that's also painful for them. And of course, also, please respect the terms of services of the data source. This is not a hacking tool. So yeah, also keep that in mind. Yeah. Yeah, so there's this trust assumption. So what does it mean? So imagine that the prover is running the notary, then we're back to square one. And then it doesn't help. So the notary needs to be neutral. If it's 2 parties and they collude, again, so if it's about a lot of money, it's more careful. You have to be more careful than if it's just like, if you need to have a Tesla to be in an anonymous Tesla chat group, it's not that bad if somebody cheats. But if this is a multi-million-dollar deal, then you need to be more careful, definitely. There are already startups like looking into like eigenlayer solutions with slashing if notaries cheat. But we're also like looking into doing like this is like a two-party computation. Like it's possibly also possible to have like do your request if it's high value, do your request with 10 notaries. That will be probably a high cost then, but if it's worth it, it could be. I'm not sure why that's relevant, but so there are solutions. You could also run a notary in trusted environments. There's all kind of research also going on there, but maybe we should discuss that at the booth. Yeah. Yeah, more questions. Oh, I have to wrap up. Sorry. So for more questions, visit us at the booth. That's also where the real experts are. I'm only the spokesman. So thank you for all the good questions, and I wish you a good hackathon.
Okay, perfect. Can we test the? Oh, there we go. Perfect. Nice. We'll give it like one more minute. Okay. Great, perfect. Okay, let's get started. Hey everyone, thanks for being here. This is just going to be a quick intro to ApeChain. ApeChain, for those who don't know, is the blockchain being built by a bunch of teams, including the ApeCoin Foundation, which is the one of the teams that kind of evolved out of like the Bored Ape Yuga Labs sort of project, and us, Caldera, which is like a rollups as a service company. ApeChain is an Arbitrum Orbit L3. So I'm sure folks who are deeper in the Web3 space have kind of seen this term thrown around a lot. Effectively, an Orbit L3 is a chain that's built using the same software as Arbitrum and settling on top of another rollup, generally an L2. For ApeChain specifically, it's settling on Arbitrum 1, or in the case of the testnet, Arbitrum Sepolia. But Orbit L3s can be, settle on basically, any L2, but typically they're built on top of Arbitrum. When you're using Orbit, you have many advantages. It's effectively the same technology stack as Arbitrum with potentially minor changes. This means you get full EVM equivalence. So for anyone who's developed smart contracts on either Ethereum or Polygon or Arbitrum, et cetera, the experience for developing on ApeChain should be no different. It's also highly performant. It's very secure. Arbitrum is the first rollup to have working fraud proofs, which means that the chain can actually inherit the decentralization and security properties of the underlying chain it settles on. Because this is an L3, it's kind of inheriting those properties from Arbitrum, which in turn it inherits those properties from Ethereum. So the chain still is credibly secured by Ethereum. Very, very performant. That means that you can write all sorts of different applications that really leverage a lot of compute or storage on chain should still be very viable. And also, ApeChain specifically uses AnyTrust, which is the same technology that Arbitrum Nova uses to offer even lower cost transactions via off-chain DA. In terms of like the features and the configuration of this chain, one thing to note is that there's a quarter-second minimum block time, which is really great if you're building anything in like the gaming or social space, anything consumer that requires really, really fast UX can basically build close to real-time applications. This block time, however, and you'll see this later, Arbitrum stack chains, they have a variable block time. So no blocks are produced unless transactions are sent to the chain. So for practical purposes, this block time may be higher or lower depending on the transaction activity on the chain. But if you're throwing a lot of transactions at the sequencer, you will get 25 seconds for a confirmation. This chain also uses Ape, the ApeCoin token, as the native token. So rather than ETH as the native token or like Matic on Polygon, et cetera, balancers are actually denominated in Ape. When you open up MetaMask, it'll say you have X Ape in your account, that sort of thing. And just like other rollups, this chain has a native bridge. Because we're settling on Arbitrum Sepolia, that native bridge is between ApeChain and Arbitrum Sepolia. So you can use that for message passing, and you can use the same SDKs and contracts that one would use with Arbitrum chains, between Ethereum and Arbitrum to communicate with Sepolia. So if you're doing anything that requires cross-chain connectivity, that would be a good place to start. So to get started, we've put together a little hub page. This can be used to connect your wallet, add the chain to MetaMask and get funds to develop with. I'll give a quick demo of that right now. So once you go to our hub, you'll see this. There will be a button here to connect your wallet. We support most of the popular browser-based wallets and also mobile wallets via Wallet Connect. Should just be able to click MetaMask, add it to your MetaMask, and maybe I'll remove the network from my account just to showcase what that would look like. So if you're coming here from like a fresh MetaMask, you will, you'll get a message like this. You just need to click right here. It'll add the network to your wallet, and then it'll allow you to switch to it. And this name Jenkins is kind of like a in-joke in the Ape community, but it's just the kind of code name for the first iteration of the ApeChain testnet. So now we have the network added to our account. As you can see, balance is denominated in Ape. What we can do is we can click the faucet here and request funds to our account. And we should see our balance tick up by 5 ape pretty shortly. Occasionally, there we go. Sometimes takes MetaMask a little while to update. It's on like a 10-second timer. Great. There's also other infra that is included with the chain. We have an explorer. I actually just asked our engineering team to allocate more resources to this, so it might still be down. Yeah, it is. But effectively, this is like a version of Block Scout. It follows the standard interface that all Ethereum explorers follow. You can get balances, block details, etc. There's also a really cool API. You can use this in your front ends or your back ends to get high-level information of the chain. So if you want like a list of latest blocks, list of transactions, transactions per, get information of a specific transaction, transactions by address, specific address info, and it also has high-level APIs for tokens. This is especially important because manually indexing tokens is very annoying. So if you want to, for example, get metadata for NFTs, get the holders of either a 721 or ERC20 token or an 1155, you can do it here. And you can get transfers, etc. So if you're building anything to do with tokens, which I imagine most people will be, these APIs should be very helpful. As well, information about smart contracts. You can. There also is a verifier API. I'm not sure if it's actually in here, but you can go to the Block Scout documentation to get high-level instructions for verifying the contract. Should be fairly similar to how you would do it with EtherScan. Yeah, so we went through the API docs. There's also a status page. If you're experiencing any issues with the chain, you think the chain is down, maybe check here first. There should be a way through this to alert our team if you have any issues. But of course, there'll be people on hand at the hackathon here to help as well. Cool, so let's quickly deploy a contract. As mentioned, the developer experience for ApeChain should be very, very similar to what you're used to if you're used to building Ethereum applications. I'm just going to do this in Remix, which is like a web-based IDE that the Ethereum Foundation provides on their website, remix.ethereum.org. We're just going to quickly create a quick token. So they actually have a great template here for ERC20s. Make it mintable. Start a new workspace. So we've got a token here using the OpenZeppelin ERC20 interface. For folks who don't know, OpenZeppelin is just kind of like a library of, really solid audited smart contracts that are commonly used, including ones for like tokens, ERC20s, 721s, etc. This one we're using their standard ERC20 interface as well as it's ownable, which means that there's like we can probably click into this. It basically means that there's like an owner variable in the contract that will be set to my address because I'll be deploying it, and we can use this modifier only owner to designate contract methods that only the owner is allowed to do. In the case of this ERC20, that is mint. So I will have mint authority on this token, nobody else will, but everyone else will be able to use the standard ERC20 methods, transfer, burn, approve, that sort of thing. So yeah, we will call this test token. Set the symbol to test. And then we will be able to just deploy it. So with Remix, you're able to use an injected provider, which is just your wallet on your wallet extension on Chrome. We're already on that ApeChain network. You'll know you are when you're at chain ID 1798. We have enough ape to deploy. Then compile this. and deploy it. And I'll set my address as the initial owner. Great, so you saw it's effectively instantly confirmed, testament to the speed of the chain. Let's see if the Explorer is back up. It is, there we go. So we saw this is that mint transaction right there. Or sorry, not mint transaction, the contract creation transaction. My address created this contract. You'll see, here it is. The indexing takes a little bit of time, but shortly after this, in a few minutes, there'll be a line here that contains more information about the token itself. Here we go. So we can see, oh no, this is my old one. Yeah, so this is my address, created that token. Now we'll mint some to ourselves. Remix provides a basic interface for interacting with the contract after you create it. We will mint this token to our own address. And the amount, as most folks will know, this ERC20 will use 18 decimals, just like ETH, which means this amount, integer, you need to take the balance you want to mint and multiply it by 10 to the 18. So we'll just do one with like a bunch of zeros. Should be more than enough. Send that mint transaction. Confirmed. Here it is. So I've just minted a bunch of test token to my contract. As you can see now, BlockScout has started to index this as an ERC20, which allows you to use those higher level methods in the API that I demonstrated earlier. So yeah, there we go. Of course, alongside with Remix, we have some docs, but you can use basically any Ethereum dev tools that you want. We have common guides for Foundry and Hardhat, and that should be enough to get you started. At the event today, there are 2 prizes for ApeChain, one of which is the best infra project. So this is infrastructure that allows communities from other chains to participate. So things like asset mirroring, interop, bridging, that sort of thing. And then, of course, there's best DApp, which looks here to be GameFi or SocialFi, so consumer types of applications. We've compiled a list of useful links. The most useful is this short link at the top, bit.ly/ETHGlobal. That'll be a link to this deck, which you can use to grab all the other links. The hub page with that faucet, RPC details, etc., is this link that you'll definitely need to get started to get funds, etc. And then everything else, docs, Explorer, status page, etc., and some dev tools are down here. As well, also want to flag this. Arbitrum is EVM equivalent, so most folks should have no issues, but there are some differences between the EVM on Arbitrum style chains and the EVM you might be used to on Ethereum. It's mostly to do with block numbers and time, specifically. So if you're running into any issues around block.number not returning the value that you expect, take a look at this document, and it should give you some ways to solve that problem. And yeah, that's it for me. Any questions? Yeah. Jenkins is just the name of the ApeChain testnet. Cool. Awesome. Thanks, guys.
No,
Mira, a ver si...
pero
Bueno,
tiene USB-C, eso sí, así que necesito
¿y tienes dos? Ah, sí,
Sí,
tienes
tengo
dos.
dos.
Es que, ¿sabes qué? Hace rato lo conectamos con HDMI y como que la frecuencia estaba... Pues no se veía muy bien.
Bueno, métele ahí, conecta por ahí. Tengo suficiente batería, sí.
Y este es Ethernet, por si quieres hacer una demo.
Ah, vale, guay. No, no hace falta.
¿No? ¿Te lo
Quita.
quito?
Sí, quítalo porque ya lo tengo conectado con el mío. Déjame comprobar que todo va bien. Internet va bien aquí.
Tres cositas rápidas. Hablar por favor a los micrófonos.
Vale.
Si te vas a parar, te traigo un micrófono para que hables.
Sí, es que me muevo mucho.
¿Sí?
Entonces, si me traes un micrófono, casi mejor, sí. Si
Bueno.
no te importa.
No, a
Si
mí
no,
me importa.
yo me quedo por aquí y ya está.
Como tú gustes, pero el caso es que se tiene que grabar porque hay personas que lo van a ver desde otro punto.
Total,
¿no?
sí, sí, sí.
Y si alguien te hace una pregunta, ¿podrías repetir la pregunta tú acá?
Sí, claro.
Porque no la van a escuchar.
Sí, claro,
otras
claro.
personas.
Sí, sin problema. Déjame comprobar que todo esto va bien aquí. Vamos a dos. Maravilloso. Ok.
¿Podemos proyectarla para ver?
Sí, sí, claro. Okay. Can you guys see the code there? Yeah? All right. I can make it bigger, but I think it's okay, yeah.
So here's the microphone.
Vale, perfecto. Vale, ¿tengo que
No te
encenderlo o
estorbe,
algo?
ya está encendido.
Vale, bueno.
Hola, hola.
Genial.
Porque aquí te puedes tomar. ¿Necesitas una botella de agua?
Ahí sí, gracias.
Hay que esperar porque la gente sabe que empieza...
Sí, sin problema, sin problema. Yo espero por aquí.
Te dejo la agua.
Gracias. All right. Can you hear me well? Yeah? Everything good? All right. Hello, everyone. My name is Jose Franco. I asked for the microphone because I move a lot, so. We're going to talk today about Arbitrum stylus, and specifically, we're going to talk how to upgrade a contract that is written in Solidity to a Rust contract, right? Through proxies. Then first of all, my name is Jose Franco. I'm an integration engineer at Off-Chain Labs. Here are my Twitter and Telegram handles. I don't write a lot on Twitter, but you can contact me there, and Telegram, of course. And Off-Chain Labs, well, we are the initial builders of Arbitrum 1 and Nova before they were transferred to the Arbitrum DAO. And we are the developers of Stylus and Orbit. So for these hackathons, we have specific price tracks for Stylus and Orbit. If you want to know more about specifically Orbit, we are going to learn about Stylus today. Just go to our booth and we'll be more than happy to help you. All right, this workshop is divided into two parts. The first one is just an introduction to Stylus. We're going to talk about what it is, what it enables, and what benefits it has. And then we're going to show a simple counter contract written in Rust, right? And the second one is a bit more advanced, and we're going to talk about how to upgrade this Solidity contract that you have behind the proxy to a Rust contract, what you have to keep in mind when you do that, right? And we will also see a sample project. So first of all, what is Stylus? Stylus is an upgrade to the current development environment we have for smart contracts on EVM chains, right? What that means is that if you want to write a smart contract today on an EVM chain, usually write that in Solidity or in Viper as well, right? But that's your choice. That's what you have to. That's the choice that you have, right? So Stylus, what it allows you is to write smart contracts in other languages like Rust, C, C++, and many other languages that will be interoperate with the EVM as well. I mean, so the way this works is that Stylus activates a new virtual machine different than the EVM that executes WASM bytecode, right? And that virtual machine lives alongside the EVM, and they can talk to each other, right? So if you have a Stylus smart contract, it is executed in the WASM virtual machine, but you can, from there, you can call Solidity contracts that are executed in the EVM machine and the other way around, okay? They are fully interoperable. One of the main benefits that Stylus brings is that we can access new developers' ecosystems, right? Like the Rust one or the C++ one. And these are all numbers. This is from 2022, almost 2 years ago. But probably the numbers have changed, but the ratios are probably the same. So we are now opening the development space to new communities as well, right? So more benefits from Stylus. It increases speed and reduces cost. This is generally true because WASM bytecode is going to be more efficient than Solidity bytecode. Then you have to take into consideration storage accesses and all that. But generally speaking, it is more efficient. And then also big improvement in memory usage that brings also new use cases like advanced cryptography, generative art. I was talking with a colleague yesterday, and they were able to implement this Black-Scholes algorithm that is used in finance, for example, that is very complex to do in Solidity because, yeah, you end up with transactions that spend a lot of gas. You can do that with Stylus now, and it reduces a lot the usage of gas, and those are, yeah, a few examples of what you can do. So what we have today is that besides the virtual machine, we are also building an SDK for Rust. There is another one for C and C++. We are putting more effort into Rust, so the SDK is more advanced. But actually, you don't need an SDK to write your smart contract because any language that can be compiled to WASM can use Arbitrum Stylus. And actually, we have examples of smart contracts written in Zig and assembly script. They don't use any SDK or anything. It's just a program that is compiled to WASM. It is deployed on chain, and yeah, you run it. That's it. So the next steps for Stylus and the current state, actually, we have enabled Stylus in Arbitrum Sepolia. So today you can deploy your stylus programs there and run them. And there is an AIP already in the governance forum to activate it on Arbitrum 1 and Nova. The on-chain vote will come soon. I don't know exactly when, but probably soon. And if the DAO vote for it, we will enable that on 1 and Nova. All right. These are 3 resources that I like to share with people who want to start with stylus. Don't worry about searching for these, because at the end of the presentation, I'm going to show you a QR code that has all these resources, all right? So the first one is a quick start. This is in the public documentation. It goes through how to set up your environment and how to work with a Hello World contract that is written in Rust, how to deploy it, how to use the Cargo Stylus tool that we use for that. Then we have the Stylus by example. That's another different portal that contains information about how you can do certain things with using the Rust SDK. For example, how do you emit a log? How do you handle errors? How do you, I don't know, encode function selectors, stuff like that, all right? And finally, Awesome Stylus is a repository of code that's been written by third-party developers, and we maintain there, so you guys have examples of things that you can do with Stylus, right? All right, so first example. This is a basic counter contract. It just has one variable that is a counter. You can increment it. You can change. You can set a different count and all that. So this is a perfect example to see for a Rust smart contract. We are going to take a look at it now. All right, here it is. So for those of you who are familiar with Rust, you will see that this structure that we have here is similar to what you get when you create a new cargo project. Actually, the projects for Stylus are created with cargo. So we have our SRC folder, and we have a main file and a leave file. The main file, we usually only use it to be able to export the ABI of the contract that we're going to write, right? So the main entry point for the contract and the main file that contains the contract code is the lib file. And in here, this contract is very basic. It only, well, it's called a counter. It only has one storage variable. I'm going to explain this now. And these 3 functions, get, set, count, and increment, right? Okay, so I'm going to explain these things by explaining what specific Stylus macros we have here. And the first one that we have is this solidity storage macro. And this macro tells Stylus that the next struct that it's going to find defines the storage layout that our contract is going to have, right? So in this case, we only have one variable, one U256 variable named count, and that's it. The next one that we have is entry point. Entry point defines, well, tells Stylus where the execution of the smart contract begins. That means that if whenever you call this contract, you are telling Stylus, hey, whenever you receive a transaction, you start executing code from here on, right? So usually these 2 macros go together, solidity storage and entry point. The last one that we have here is external. External tells Stylus that the next functions that it's going to find are public functions. They can be called from outside the contract, right? If you want to implement any private contract, you can do so by adding another impl counter above the external macro, and those will be internal, right? Okay, and as I said, these 3 functions, well, the get function only returns the count. The set count sets a different count, a different number in the variable, and increment, well, increments by 1. Another thing to keep in mind here is that when building the Stylus, when we compile the Rust code into WASM, we change the code and we change the functions so they are Solidity ABI compatible, okay? What this means is that we want users to not care about what language the contract is written in, but we want them to be able to call them the same way they call Solidity contracts, right? So for example, we have here a set count function that is using Rust syntax. It's using snake case, right? But this is not the way Solidity ABI functions are written, right? So when compiling this program, the SDK is going to change this. So when you call this function, you will have to use camel case, the same way you do with Solidity, all right? And that being said, I think we have time to quickly run this example. We have this, I can answer questions later, okay? We have also this script folder that holds, scripts to perform individual operations. So if we call, for example, the deploy function here, the deploy script, I need to go to scripts, deploy. It's going to deploy our program. We can take a look at it. It actually uses the cargo stylus tool. I don't want to go into details about this, but you have that in the documentation. And then, so our contract is now deployed to this address. And we can, for example, get count here. I have this comment to help me with this. We get the count. The counter is 0, obviously, because we just deployed the program. We increment it. Yeah, okay, and then we get the count again, and it's 1. So as you can see here, we are using actually Foundry cast to call our stylus program, the same way you would call a Solidity program, right? And if we go to the set count script, it's using cast send, and as I said before, it's using set count in camel case, okay? So this is going to be important for what we're going to see later. All right, let's go back to the presentation here. All right, let's go to the second part. Now, I'm going to talk a bit about upgradability of smart contracts. You probably know everything about proxies and all that, but in case anyone hasn't worked with proxies, let me just cover the basics to understand what we're going to do later. So as you know, smart contracts are immutable. That means that when you deploy the bytecode, you cannot modify it, right? But obviously, sometimes you want to have upgradable smart contracts because you want to be able to fix bugs. You want to be able to improve the logic of your contract. So how do you obtain upgradability? Well, one of the most common patterns that we use are proxies, okay? And proxies are just smart contracts that are deployed in front of a logic contract, of the contract that has the business logic of your application. So let's say that, for example, you want to have you want to deploy an ERC20 contract that is upgradable. You deploy the ERC20 contract, and in front of it, you deploy the proxy. Your users are going to call the proxy. They are only going to interact with the proxy, and that contract is going to delegate call the ERC20 contract. Then if you want to upgrade the logic, you just deploy a new ERC20 and point the proxy to that one. So whenever the users call the proxy contract, the call will be forwarded to the new logic contract. Then what happened with the storage? Because we are delegate calling from the proxy, we are using the storage space of the proxy contract, right? And this is important because otherwise we will use the storage space of the logic contract, and if we change it, well, we lose all the information, right? So one thing to keep in mind when upgrading is that you need to keep the same storage layout as the previous logic contract. Otherwise, you will be messing with the slots, and I don't know, if you change the balances mapping with the owner's mapping, you might be asking for the wrong information later, all right? However, you can extend it. If you keep the same storage layout and you add new variables below, you can extend it, and yeah, just keep in mind that for the next one, you have to keep the same storage layout. And the other thing to keep in mind is that logic contracts shouldn't be initialized with a constructor, because if we are modifying the storage in the logic contract directly, we are not modifying the storage from the proxy, right? So what we usually do is that we initialize the contract. I don't know, in the case of an ERC20, We set the name and the symbol, for example, from a special initialization function that we call from the proxy. So, oh yeah, one thing to keep in mind is that I'm giving a very basic explanation of proxies. So proxies are very complex and can do a lot of things. This is just the basics to see what we are going to see today. There is a lot of information on Google. I'm more than happy to talk about proxies as well, but yeah, just keep in mind that these are much more complex. So requirements of the proxy pattern that we are going to use. The logic contracts, these ERC20 contracts, need to be initialized from the proxy or through the proxy, not with constructor, and we need to keep the same storage layout when we upgrade the logic contract, right? All right, so let's get to it then. We're going to upgrade a Solidity ERC20 contract to a Rust implementation. This Solidity ERC20 contract is going to be behind the proxy, right? So the steps that we are going to follow more or less are, first, we are going to replicate the storage layout in the Rust contract. Second, we're going to write the same contract functions in the Rust contract. We can modify the logic if we need, but the signatures have to be the same. And then to test, we are going to simulate the update flow and add any necessary functionality we need there. All right, so for the Solidity part of this code sample, we are going to use OpenZeppelin's library, right? So for the proxy, we are just using a transparent upgradable proxy, just simple as that. For the ERC20 contract, we are going to use their implementation. We are using here the standard, the non-upgradable implementation. They have an upgradable implementation for the ERC20, but we want to keep the storage as simple as possible. The upgradable uses a specific storage slot. We want to start the storage slot in the slot 0 or whatever the slot we start from. And we are also using the initializable library to be able to initialize the contract through the proxy, right? So one thing to keep in mind here is that the initializable contract, when you inherit from it, you are adding two storage variables, two special storage variables to your contract, right? And because we are inheriting from that one before the ERC20, we are going to have those two storage variables first, and then we will have all the storage variables for the ERC20 contract. We need to keep that in mind when we build our Rust contract. And then we have just the initialize function. I'm not initializing the token name and symbol here. I'm just hard coding those values because I want to make this simple. And we have one mint function. All right, so let's move to Rust then. When we write our Rust smart contract, the first thing we are going to do is to replicate our storage layout. And here I want to show you a different macro that we can use as well, which is sol storage. This one is different than the previous one. The previous one was solidity storage, and this is sol storage. The difference between those is the syntax that you are going to use for your variables, right? So for the previous one, we use Rust syntax, and for this one, we are using solidity syntax. This is interesting, especially for these use cases, because if you are familiar with Solidity, if you are a Solidity developer, it's very easy to copy the storage layout that you have and paste it as is in your Rust smart contract. If you are a Rust developer and you don't know anything about Solidity, it doesn't matter, you just write with Rust syntax. Okay, and here we are using also a borrow macro, because in this specific example, we have our ERC20 implementation is in a different file. I wanted to show you a more complex example. So in this case, everything that is ERC20 is in a different file, and then we call that module from our first lib module. We will see that in the code later. Yeah, so then we're going to write the same functions in our Rust contract. We are using another special macro here, this inherit macro, that is going to take all the functions that we have in this ERC20 module, and they are going to add it to my token. We are adding a new burn function here that we didn't have in the Solidity contract. Yeah, that's it. So 3 contracts, proxy and ERC20 in Solidity. Those are going to be deployed with Foundry. And then we have the Rust contract, the ERC20 Rust contract, that later we're going to deploy and change the proxy contract to point on that one. All right, so let's take a quick look at it. Ooh, bad time to be signed out. It is this one, yeah. So this is the QR code that I'm going to show at the end. Is for this repository. The README of this repository contains all these resources that I talked about before. In this project, we have 3 main folders. We have the proxy, which is just a Foundry project that contains the proxy code. Then we have the ERC20 Solidity that contains my token, similar to what we saw before, but with a few things. I had to add a constructor here, even though it doesn't do anything, because I'm not using the upgradable. And yeah, OpenZeppelin requires to have the constructor. The initialize that we saw before, the mint, and the hard-coded name and symbol. And then we have the Rust contract here. So the Rust contract has the main file, the same as before, just to export the ABI. And then we have the lib and the ERC20. The ERC20 has what I said before, the implementation of the ERC20 standard, right? It uses the Sol storage that handles Solidity syntax. So it has balances, allowances, total supply. Then we have our events and errors that we can emit and throw. And then in here, we have an impl of the ERC20 that doesn't have the external macro that we saw before. That means that these functions are internal. They can only be called from within the contract, right? We have our transfer, we have our mint, burn, all the internal functions that we need. And then we have a different impl, ERC20, with the external macro. So these are the functions that we can call from outside the contract, right? The name, symbol, decimals, total supply, well, everything that we need. So notice that even though in Solidity we have transfer from in camel case, here we are writing in snake case because we're writing our Rust contract. So this is going to be compiled to WASM. It's going to change the way we call it. So it's going to be compatible with the proxy that we are using, okay? Users are not going to notice any difference there. All right, so from the lib file, in the end, the lib, remember, is the entry point for our contract. So even though we have the ERC20 file, all calls are going to go through whatever we have in lib first, right? We are using the ERC20 module that we just saw. The Sol storage is what we saw before. Remember that we had 2 variables, 2 storage variables that come from the initializable contract. And so we are putting them first, and then we are borrowing the ones from the ERC20 module. And we have the mint function and the burn function that we are adding, all right? I think we can do a quick test here. For the scripts folder, we have the same thing here. If you want to run it, we can just deploy it. One test that I like to do, let's see if I can do everything with one hand. Deploy. So deploy, it's only going to deploy the Solidity contracts. All right, so we have the proxy here. We will need both the proxy contract and admin for later. But for now, let's get the token information here. Let's see. All right. So let's get the token information. Let's mint some tokens. Yeah. I'm not sure I have time for the full demo, but let's try. Yeah, and let's get the balance. All right. So here for the balance, I'm just using the deployer account. All right. And now what we are going to do, if I can, is to upgrade the contract with the update logic script. For this one, we need the proxy contract and the proxy admin, because we need to send the update call from the proxy admin address, right? Copy and so this is going to deploy the Rust contract using cargo stylus, and then it's going to call the update function of the proxy contract. So now, if we go to the get information, we'll see that we have now the my token v2, so it's using the contract, the Rust contract, and if we go to balance, we should have the same balance as we had before. So the first that were minted on initialization, and the last 100 tokens that we minted with this. All right, so I don't have more time, so I will just show you the QR code. If this allows me to show you the QR code. Ah, no. Well, I'm going to, yeah, I'll do another thing. I'll write on Discord on the ETHGlobal server. I will send this presentation. I will send you the link to the repository actually that contains everything. And yeah, you can grab it from there, okay? I will send it in the partner Arbitrum channel of the ETHGlobal Discord. And yeah, thank you very much. I don't know, I think someone had a question before. I have 1 minute left. Yeah.
First, you have your own implementations of ARC and not something like Open Zeppelin library
For stylus?
for stylus, yes, for Rust or C++.
I think they are working on a library for Rust contracts. I can try to dig in some information and see what I can find. I think they actually publish it on Twitter, I think, if I remember correctly.
Okay. The second question is, so there is these getter functions. So does your compiler understand that this Rust code does not change anything since hence it's a view function? Or is there a way that I mark the function as view, for example?
Oh, I see what you mean. I'm not 100% sure, but I believe if you don't modify the storage, it's just going to mark it as viewer. Yeah, it should. The SDK, the Rust SDK.
Rust understands if I'm modifying a variable or not. So
yeah, so the SDK probably when it compiles it to WASM, it will just mark it as view.
okay, do I get to? Is there syntax similar to modifiers or?
Yeah, well, actually what you can do is that, well, we had several macros that you can use, and you put them in top of the function, and then give you, for example, for a payable modifier, we had a payable macro, and you put it on top of your function, and then it makes it payable, for example.
Okay,
all right?
Somehow I can use similar macro that say, again, modifier, for example.
Oh, you mean for modifiers? Yeah. Okay. Sorry.
This owner, for example.
Yeah, I don't know. I can find that out, but yeah, but I don't know if you have the same behavior as modifiers in Rust.
So it will ultimately be API compatible with Solidity.
Yeah, the same.
I can write, if I can write that code specifically at the start.
Yeah, exactly.
But I still want to be compatible with Solidity APIs, like you mentioned.
Yeah, it's going to be compatible with Solidity APIs. If you want, because I ran out of time, if you want, we can talk about it in our booth. I don't know if we have time. No. Okay. So yeah.
If there are questions, they can go with you to the booth.
Yeah, exactly. You can go to our booth and we will talk, or even outside here. Thank you very much.
Some of the data,
Yeah.
some of the different data.
Sorry, tell me again.
Are you presenting a demo?
No.
No. So, can I connect it?
Yeah.
If you meet to present a demo or something on the internet, I suggest to connect this because it's Ethernet. So we'll run smooth.
Oh, okay. You can just connect it in. Thank you.
Okay, you're welcome. Some things. Please talk directly to the mics.
Okay.
Are you walking around?
No.
Okay, perfect. If somebody asks a question, could you repeat the question so that people in the watching the video can actually listen to it?
Okay, sure.
Yes, please.
It's not connecting anything.
To this one. Here is flashing, so maybe it's going to appear now.
It's no
Network?
Wi-Fi, right?
No,
Network.
it's not Wi-Fi. So
Connected.
is that one? Can you try?
I mean, trying. Okay.
Now it's loading.
Okay. This will load now.
Thank you. Did it load?
Okay, it's loading now. It's loading now. I got it. Yeah. Great. Oh, thank you.
Yes.
Maybe you can. Mais tu peux appuyer sur 2, le bouton orange. 2, le bouton. Attends.
And
Yeah.
it's 28 minutes.
Okay.
So I will tell you like 5
Okay.
before you end, and then 2. Is that okay?
Yeah.
Okay. I'll do that.
Okay.
Send your presentation. Ça c'est connecté. Donc ça c'est internet, ok. Ça c'est HDMI.
Yeah. What do you need?
For now it doesn't work.
Right. Yeah. I don't. What do I need to do?
You have only one screen.
And let someone else. Yeah, only have one desktop. Oh, there's another one. Maybe. I don't think so, but there's only one desktop here. Hello. Sorry, give us a second. We'll get started real soon. I have faith in the AV team. Okay, maybe while they get the presentation set up, I'm going to introduce myself and then kind of get a sense from everyone here on what they are trying to build so that I know what's the best thing to share with all of you today. Because I know you only have like less than 48 hours to hack. So we want to make this as painless and as easy as possible. So nice to meet all of you. My name is Sarah. I am from Filecoin, and I'm part of a developer experience team called File Builders, and we focus on building out easy DX resources for Filecoin. So just a show of hands from everyone, how many of you know what Filecoin does? Okay, great. Have you all gotten your t-shirt at the booth? Yeah, yeah, okay. It's kind of like this, which is our white paper. So, huh? Yeah, but the white paper is on the back, on the one in the booth. Yeah, mine's special. So, yeah, but it's cooler. The one at the booth is cooler, and you need to know something about Filecoin to get your t-shirt. So you should pay attention for this presentation and then go get your swag. Yeah, cool. How many of you have used Filecoin to store your data before? Okay, and could you retrieve that data? Yeah. Okay. So I'll run through why that is so and what is the advantages of storing it on Filecoin versus pinning it on IPFS, which I'm sure everyone here IPFS, yeah. Okay, yeah, super easy to use, right? The best way to use both is kind of to have a combination, and I'll kind of explain why in a little bit. For today's presentation, and I know the bounty is about creating storage use cases on Filecoin, AI on Filecoin, and privacy-preserving applications. Those are like, so what I'm going to run through today is foundations of Filecoin and how your data is actually being stored. It is not that not that simple a protocol in terms of how we get data stored, but we have SDKs that will make it super easy for you to use. It's just that it will be useful for you to understand how that is actually being packaged and where your data is actually sitting, so that when you create an application, you'll know any troubleshooting issues, and we'll also be at the booth to help out. Okay, so let's hope this works. Okay. Oh, you have one? It is a HDMI to Type C, but yeah, if you have one, or if anyone has one, like a port. Yeah. So who here is building an AI use case for their project? Very nice, very nice. What are you using for your computation? Okay, cool. We actually have some data sets on Filecoin that you can use that will be easy for you to retrieve, and you can run your computation on top of that. So hopefully that will make it easy for you. Okay, thank you so much. Let's try this.
Direct HDMI?
I'm gonna try this one. No, it doesn't work. This is like, yeah, as expected. Haven't even gotten to the demo and this is not working. This is yeah, it's a slide deck on Google. Can we share it?
Yes, preferably.
Is it my MacBook?
It's MacBook problem, yes. It's typically the MacBook problem.
I send it to. Which one? No, this is all their setup. So I have this, and then I.
Right, but this has to go to the power. And power it and connect the charger to it. instead.
Maybe.
Yeah, now connect the charger. This is the charger.
Oh, hold on. Wait, this looks like it's working. Wait. Does it work now? But it looks like my screen connected. No? Yeah, go ahead.
Could you send it to me?
Okay, thank you. Oh, whoever the two people that helped me just now, you get extra swag. Come by the booth. Thank you. Okay, great. We will now get started. Okay, we can do this. We can do this in 20 minutes. No, come on. All right, cool. So we're going to run through Filecoin storage for building resilient applications. As I mentioned, my name is Sarah. If you want more updates on DX resources from Filecoin, we recently posted some template contracts to do cross-chain payments, and there are more things you can find in the documentation, which is docs.filecoin.io, or you can follow us on Twitter for @philbuilders for more technical resources to come. This. There is no story to it. Just to clarify, trucker fling means nothing, if anyone asks, okay? All right, cool. So Filecoin TLDR, it is a crypto-powered storage network. We have one of the largest decentralized storage networks around with a huge storage capacity. And what we're focused on is getting more data onto that already committed storage capacity from our storage providers, and also to enable, now with the FVM launched, new DeFi applications around the Filecoin network, because collateral is very different in the Filecoin network. It is based off hardware and it's really high too. So there are a lot of opportunities for the DeFi space on Filecoin. So yeah, how have we been doing since we launched the Filecoin virtual machine back in March 2023. I was part of the team that was launching it. And so we've been working very, very closely with builders. You probably see me and my team at different hackathons now. We've had about 4,000 unique contracts deployed to date, and that's still growing very steadily over time. Yeah, if anyone's curious, this is built by Starboard. So if you just search Starboard Filecoin virtual machine, you can check out the stats for our contract deployments. So high level, what is the Filecoin master plan? It started about 7 to 8 years ago. We started with IPFS, which is why everyone knows and loves it well. That, to clarify, because we have had this question very often at the booth, I also took a really long time to kind of understand the difference, and I don't want to assume. IPFS is not on the blockchain, it is P2P network. And so if you store data on IPFS, you're effectively pinning a copy of your data on a node that is, unless you pay like an Infura or a Pinata, it is not actually going to store your data. The node might actually go down. So if your peer-to-peer network goes down, your data disappears. So those are the trade-offs with IPFS, but it is very fast, and it's fast to pin and it's fast to retrieve. So now we go outside of IPFS, we go on to Filecoin. So you have the Filecoin layer 0. Filecoin itself is a protocol that represents all the different storage deals that are made on Filecoin. So your data is not actually stored on-chain. It is stored, of course, with storage providers that are represented on-chain, and they get slashed if they do not guarantee your data to be available when you want to retrieve it. So that is how the Filecoin network works. On top of that, we've launched a Filecoin virtual machine last year, which is to enable programmability. So before this, you could not do any kind of dApp development on Filecoin, but today you can. The Filecoin virtual machine is also fully EVM compatible. There are some opcodes, and if you have questions, you can come by the booth that we are, as every EIP launches, we are keeping up with all the different upgrades. So we're not like straight off the bat, like on par with EVM compatibility, but we're mostly EVM compatible. You can use Foundry, you can use Hardhat. We have starter kits for those as well, so you should be able to build your dApp. And then very recently, back in about November last year, we launched the Interplanetary Consensus. I won't run through that today, but it is a resource that you can use, and you will qualify for the bounty if you want to use it. Just an FYI, IPC is a framework kind of similar to Cosmos, but built for Filecoin, where you can build your own chain or layer 2 on top of Filecoin today using the FVM under the hood. And what that allows you to do is to build custom syscalls to do with storage. Yeah, and built-in actors on Filecoin. So you could build a very storage-focused layer 2. So yeah, that's kind of storage evolution of Filecoin. And so I'm going to get into the mechanics of how you do data storage. Some of you might know this, but most people do require like a little bit of a refresher on this, and then we'll get into the tools that you can use, and then all this will make sense. So data storage 101 on how it works on Filecoin. You start with a file and you have your own file. What happens then for your file to get stored onto the network? You have to prepare that data and turn it into a CAR file, which is a content archive file. So content archive files are a special way of packaging your data such that it can be represented across IPLD nodes. IPLD is kind of like a complementary feature to IPFS, but it allows you to content address the different parts of your file that you're trying to store. So it's important to prepare your data into a .car file. If not, it can't really get stored on the network. Once it's packaged into a CAR file, it gets represented by a content ID. And so CIDs are very important. If you've used IPFS, you would have seen this around. When it gets stored on Filecoin, it is also represented by a content ID. So these are really important. Once you have your content ID, your storage provider will then take that content ID, find the .car file that is related to it, download your .car file through some kind of buffer. Maybe it's across HTTP, maybe you put it into a Dropbox, maybe you mail it across. Totally up to you. They'll download that file and they'll put it into a storage deal that then gets represented on the blockchain. So TLDR, this is very high level on how Filecoin works as a protocol. Okay, so we're targeting some key use cases here. I can go on, and Juan and the entire Filecoin ecosystem has like so much information. Like, the people are brilliant, but we're going to target some really key use cases that you will use within a 48-hour hackathon, which is namely to store small data either directly to Filecoin from a dApp built on Filecoin, or storing small data from a dApp that you have on a different chain and how you can access that. The other one we'll run through is how to store larger pieces of data, and then I'll show you some easy cookbooks that you can use for your hackathon. So if you're storing smaller pieces of data, and this refers to things that are smaller than 1 gig, like really, really small images, we have what we call storage on-ramps, which are like lighthouse.storage and web3.storage. And what they've done is to provide an SDK that you can use, available in TypeScript or JavaScript, and you can use it across cross-chain from any dApp that you have deployed onto. If you're deploying on Polygon, you can just call this and then store the results that you have onto Lighthouse and web3.storage. So what happens there on the back end, and you can scan this QR code, it will bring you to those sites and you can use the SDKs. What will happen in this case is that you upload your files pathway. So, in your desktop, what is the pathway to your file? How do you download it? The storage on-ramp will then package the data for you. They'll prepare it into a .car file, which I mentioned earlier on, and they'll give you a CID because they're pinning it to IPFS, but know that that CID only represents the copy of your data that is on IPFS so that you can do quick retrievals. So if you have a dApp that, every transaction you need to store, retrieve, IPFS is really important here, but to have long-term guarantee of your data, it will also store a copy and a backup onto Filecoin. The process that I showed you earlier on, from a CID to a storage deal, can take anywhere between 24 to 48 hours because sealing is a computation-heavy process, and it also requires a storage provider to receive enough data to want to package it into 32 gigabytes of data, which is the typical sector size. It's a whole process, we won't get into it, but that's why your deal takes 24 to 48 hours. So these are a really good stopgap for you to use as a solution, so you can serve the needs of your dApp, but also get that data guaranteed on backup for long term. Okay, and if you want to manage small data, so the cool thing about Filecoin, and I think this is a little bit different from what you can do with other platforms out there, is you can actually programmatize how you want to store your data. So and Lighthouse is a really good example of this. This is a different QR code that goes to that one page where they have offered a new feature that we built with them called RES. RES stands for Replication, Renewal, and Repair of Your Data. So when you upload your small piece of data, you can specify how many copies you want to have, how often, or any conditions you want for replication or repair and renewal of your data deal. So for example, the duration is only for 5 months. Maybe based on a certain condition, it will then renew that deal after a certain period. Or if the sector breaks, it will identify the issue and then fix it for you. So you can specify all these different parameters within the Lighthouse SDK, and it's still within the SDK, so that's really amazing and easy to use. And once again, pin to IPFS, store to Filecoin, you can then retrieve that data. So that is an additional function. I don't know what use case you want to use it for. It could be a legal use case. It could be GDPR. That's a really good one for you to check out. Okay, and then we come to storing larger data. So if you have large data sets that you want to get stored, and you don't have that time constraint of having to store it super quickly, you can consider storing it directly within a Filecoin smart contract on FVM to the Filecoin network. So I'm going to assume here, if you're dealing with larger data, you might want to build your dApp within Filecoin. If you're doing so, you can use the client contract. There is a documentation here that you can use. You will deploy the contract yourself, and you prepare your data and put it into the client contract. And what the contract does is to send a deal proposal to the Filecoin network. And we already have storage providers on the testnet that are subscribed to this contract to look out for events from this type of contract. And once they see those events, they will pick up the deal and store it for you. This should typically happen within 12 to 24 hours. That is the agreement we have with them. And so you can use this method if you're storing larger pieces of data. Yeah, and you should get a deal ID back at the end of the day. So if you don't have a deal ID, it means your data isn't actually stored on Filecoin. Yeah? Okay, so that is another method for you to use. Okay, and then it comes to retrieving that data. So for those of you who raised your hand earlier on and you stored the Filecoin, but you found it hard to retrieve your data, this is where this comes into play. So you can use Lassie, which is a very easy CLI that you can use to retrieve your data. If you have your deal ID, it should also come together with a root CID, which represents your data stored on Filecoin. You can just easily call that BAFY root CID and then retrieve your data using Lassie. So that's how you're going to get your data back. And if you want to use existing data sets that we have already stored on Filecoin for you, we've uploaded some of the popular MNIST data sets onto datasets.filecoin.io. And so you can just use that off the cuff and start building an application from there for the hackathon. Yeah. Okay, so building dApps on Filecoin, why do it? As I mentioned earlier on, if you want to, multi-chain is the future. If you have your dApp deployed on another chain, SDKs are a great way to go. If you want to build it natively within Filecoin, here are some key advantages. It's great for data-centric use cases. There's a lot of manipulation you can do with the Filecoin.solidity library that I'll share the resource with you in the next few slides to then call on Filecoin's built-in actors. So we have actors like the market actor, for example, that deals with how deals are being made, how storage providers are being incentivized. And so you can actually call those using Solidity methods and build your dApp from there. So if you have a data-centric app, great to build it there. It's also EVM compatible. And if you have unique DeFi use cases, if you want to check out Filecoin and understand the collateral network and what kind of new DeFi use cases you can build, Filecoin's interesting. We have like liquid staking pools, for example. So storage providers, which are kind of like our miners, have a huge amount of collateral to stake. That leads to use cases of like lending pools where they would like to get collateral lent to them. And then we have like fill token holders, for example, that can then put their fill into a lending pool or staking pool, and then that gets lent out to miners, and whatever they get from block rewards, which are pretty substantial, can then go back into the pool. So these are some DeFi use cases you can think of that you won't really see in other ecosystems, but we'll love to see some interesting ideas from all of you. And then lastly, cheap transactions. Filecoin in general, if you're using the FVM, it's not super widely used right now. We only launched last year. Transactions are really cheap. So if you're running an application, it's going to be much cheaper. It might be a little slower for now because we're launching some protocol changes by September that will allow much faster block time. But for now, the block time is about 30 to 90 seconds, so it might be a little bit slower. But the trade-off is that it's a lot cheaper to run. We used to have a fill gas estimator, but the tool is down for this hackathon, so I can't show you. But yeah, it's definitely much cheaper to run. So if you want to build a dApp on Filecoin, here are some tools that you can use. Filecoin.sol is the Solidity library I mentioned earlier on. We just recently did a round of audits and also made some updates to it. So it should be working really, really well right now. So you can check that out. If you want to see how to use it, some examples, we have it on the docs.filecoin.io as well. Whoa, all right. Totally awake now. Cool. You know I can just send these slides to you, right? Like, okay, I'm kidding. And then if you want some depth cookbooks, I'm going to run through this site really quickly, but we have these cookbooks ready for you to use. If you want to query chain data, we have tools that are APIs available for you. We have some oracles integrated as well. I think we have Pith and Telor. We maybe have a few more coming in the next few months, but we're building up our integrations at this point in time. But you can access price feeds there. We have cross-chain bridges with Axelar. If you follow the Phil Builders Twitter, we actually just launched some template contracts that you can use for this hackathon. So that makes it super easy to do some payments within your dApps. And then lastly, we have, if you're looking to do SQL queries, a decentralized database running on Filecoin, you don't have to build it from scratch. Tableland is a really good partner for us, and they have already built that tooling for you. So you can easily set up a decentralized database with SQL queries on Filecoin today. Yeah, so I talked a bunch, but I'm going to show you real quick. I don't know if you guys can see this. Just, whoops. Yeah, so if you want to check out the cookbooks, these are all over here for you to use. We also have, oh, I don't think that's on testnet. I wanted to show you, because Block Scout is integrating with us, and I know Block Scout is one of the bounties here in the hackathon as well. They have soft launched on Filecoin, but it's only for mainnet, so it's not for testnet. So if you want to pay Phil to use mainnet and use their APIs, like, good for you. But yeah. So yeah, all in all, that's mostly it, and I think I have some time for questions. So anyone has a question they want to ask? Yes.
What would you recommend for gated access? Do you have something there?
Gated access, yes. Let me just show you real quick. What do you mean in terms of micropayments? Oh, okay, right. Let me show you gated access first. So Lighthouse has a really easy SDK for you to use. Once again, where is it? Let me see. Yeah, if it will load. Yeah, so they have an SDK you can use. How this works is through decentralized key sharing, and that will allow you to encrypt your data before it gets pinned on the IPFS. So you can use this there. Micropayments-wise, you can use Axelar for cross-chain payments today. They do swaps. That's probably the easiest. Oh, we also have Sealer if you want to use it as well. So those are the two options for payments. Yeah. Question, I saw another hand. Just not, yes. Yeah. So this allows you to encrypt your files before it's stored to the network. If a lot of the data we have on Filecoin doesn't go through this method, right? It's only if users choose to. Privacy on Filecoin, the data is openly available, so your storage providers could technically look at your data. But yeah, they could look at your data. So it is a good idea to think about encryption. Also, regarding one of our bounties around privacy preserving tools, I would be interested to see maybe someone using like lit protocol, for example, to integrate with Filecoin through the FVM to see how you can provide access control to data. We don't have that. We used to have the integration running, but the contract hasn't been updated. But we'd love to see some new usage of third-party integrations with Filecoin data. Yeah, that would be really cool. It takes about, so on mainnet, it takes about 24 to 48 hours. On testnet, it takes about 12 to 24 hours. Yeah, but typically within 12 hours, you should get your deal. That is the commitment we have with the storage provider that's servicing our testnet. So everything should be available within the, yeah, so I would give you the link directly, but then you get lost. But if you go to docs.filecoin.io, there will be a Hi-Hat starter kit that you can access. Yeah. Yes. Filecoin and AI, we have some projects like Fluence and Lilypad that are providing like decentralized compute off of Filecoin data. Fluence itself, I think, is super new. I'm not sure if you can actually develop on it just yet. I might be wrong, but you should check it out. Oh, But can developers use it? Okay. Okay, maybe, yeah. So if you use Fluence actually backs it up to Filecoin. You could use them for decentralized compute. Lilypad is another project to check out. These are available within the cookbooks under decentralized compute. We have the links for them. Lilypad is a set of smart contracts that allows you to coordinate decentralized compute onto another network called Bacalhau. But the smart contracts are there for you to use. The last time I tried it, like 2 weeks ago, the smart contracts were not updated yet, and they were like broken, but you should check, yeah. If not, we have the team on Discord to like fix it, and we're asking them to fix it right now. That's why I didn't show it in this tutorial, yeah. That's a really good question. I think dataset marketplaces to support AI models will be very interesting. Another interesting one is if anyone can figure out traceability of generating a computation result, so traceability of data being used to run a model, that would be really interesting to see. Maybe some kind of attestation that you can see like a crowdsource of data being uploaded and the model running on top of it, and what kind of result that puts out. That would be really cool to see, yeah. Generally too, if anyone thinks about how to back up LLM snapshots to Filecoin in a really user-friendly way, that would be a useful one too. I know like quite a few clients asking for that. Yeah, I mean just some ideas to put out there, but I think these will get the team really excited. Okay, I think I'm at time, so I will stop. But I am. Okay, cool. I will be at the booth, and yes, those two of you come, I'll give you swag. Thank you so much for your help. Thank you. Thank you. What's your name? Mustafa. Hi, nice to meet you, Sarah. Thank you for your help.